Hello bachcho, Sat Sri Akal and Namaste from my side. So this is a teaser of what content we are going to study in this lecture. 7 fundamental physical quantities, the most important part of dimensional analysis. Among them, the first one is length, mass, time, thermodynamic temperature, electric current, amount of substance, luminous intensity. So students, this was a teaser of what we are going to study, right? So this champion series is for JEE and NEET aspirants, and the first lecture of this series, right, of units and measurements is loading.
Apart from this, we are going to discuss some of the most important concepts related to the Vernier Calliper, Micrometre Screw gauge, right? And some of the important questions, right? Some of the PYQs related to those. So, students, this was a teaser, right? And it was a new thing that was kept in front. Hope so you all like it. I will be waiting for your comments for this specific initial, what we can say, the entry part. Okay, if you really liked it, I will be waiting for your comments beneath the video. So, students, this is Indrajeet Singh welcoming you all. Right, first of all, sorry, I forgot it. Right. Hello, bachcho, Sat Sri Akal and Namaste from my side. So, this is Indrajeet Singh again welcoming you all. Right, okay, the most sensible platform of an edtech. Okay. Sensible platform of an edtech, right? So this is a new thing that has been, right, in my previous videos, right, I already mentioned about it, right? Something new. SPW is a box of surprises, right? A new thing is going to come in front. A new thing is going to come in front. So guys, this is a JEE NEET for JEE NEET aspirants. Commonly, we are giving one crash course, right? Okay, commonly we are giving some crash course, and according to the weightage, right, almost all of those chapters, especially if I'm talking about the physics, right, or maximum number of the chapters will be covered. Okay, we have prepared one schedule, right, and I'm damn sure, right, maximum number of the chapters we are going to cover. Okay, so obviously as usual, right, one by one, right now it is coming the lectures of units and measurement. After that, right, electrostatics will come, and we are moving on into the parallel way, right? We are moving on into the parallel manner for 11th and 12th. Okay, so champions, are you all ready? This is a champion series. Are you all ready? Yes, champions, you all are ready. Let's begin. What will be the flow of chapter? We are going to start from basics. Very basic. Basic, one sum, NEET PYQ, JEE PYQ. Lots of visualizations in front. Lots of examples from day-to-day life, because physics is nothing else but, right, the analysis of an activity is going on in around in, right, in our surrounding. Whatever the activities they are going on in our surrounding, we are analyzing, and physics and the entire syllabus of, right, 11th and 12th, right, relies on all of those examples only, right, whatever they are going on in our surrounding. Okay, so I think we should start. Okay, units and measurement. Now, in this lecture, right, what stuff we are going to cover, right, from the it is like a zero to hero, right, it is like a zero. So those who are attending this lecture till last now, I'm damn sure, right, whatever the relevant concepts are that related to the, like, whatever the relevant concepts, right, of units and measurements are there, everything will be cleared, but you have to just, right, okay, stay till end. Why? Because if I'm talking about the theoretical part of this lecture, then obviously one topic will come. We are going to discuss one example, one awesome visualization, and Directly we are going to give the question solving approach. Directly we are going to give the question solving approach. Theoretical part, it's explanation, question solving approach, sums. Question solving approach, sums. Question solving approach, sums. So obviously you will have a complete scenario, right? How things are asked from all of those topics. How things are asked, right? So that is a new thing that is going to come, okay? So in this chapter, obviously we are going to deal from the basics. So the first part would be the fundamentals. After fundamentals, right, some of the most important applications of the dimensional analysis, right? Because if I'm analyzing the past 10 years papers of JEE and NEET both, right, then some of the important questions has been asked, right, related to this concepts, right? Okay, they have asked, right? Okay, so we are also going to discuss all of those stuff also, right? And we are going to see all of those topics from basics, right? Okay, apart from that, error analysis and significant figures we are going to discuss. Vernier Calliper, right, measuring instrument, and some of the important concepts related to the Micrometre Screw gauge, like what is the least count, right, what is the zero error, right, what is a total reading, right, how VSR, how caliper readings are calculated, how screw gauge readings are calculated, right? All of those stuff we are going to discuss into the detail. You have to just stay till end. Apart from this, I'm going to give you the flow chart of this chapter. Okay, in our previous KVPY series, right, we have already, right, seen some of the important flow charts, right? Okay, but I got the idea from the rotational motion and I started from that, right? But for the crash course, obviously we are going to provide some important things, right? Okay, we are really going to provide the awesome things. Okay, so let's move on, right, without wasting our time. Okay, what will be the flow chart of this specific chapter, right? Okay, so if I'm talking about the units and measurement, obviously units and measurement, right? Okay, so the first part will directly move on to the fundamentals of the units and measurement, right? In fundamentals, right, we are going to discuss what is physics, right? What is the physical quantity? What is physics, right? What is a physical quantity, right? What are units, right? What are dimensions? What are dimensional formulas, right? Dimensions and the respective dimensional formulas, right? Right. Okay, apart from this, the solid angle, plane angle, the classification of the physical quantities, right? Okay, the classification also of the physical quantities, right? Okay, like fundamental physical quantities, derived quantities, supplementary quantities, lots of stuffs, right? We are going to discuss, and really you are going to enjoy a lot. Okay, because today I'm going to change your scenario about physics. How you are thinking about this subject, na, right? Okay, I'm going to change the scenario, and I'm damn confident about it, because the way of, right, teaching in this lecture, right, will be really up to the next level. Okay. So you have to just stay till end. Okay, so apart from this fundamentals, obviously we are moving forward to the next part, right? Dimensional analysis, right? The first one, that is, okay, dimensional analysis. In this dimensional analysis, right, we are going to discuss some of the important applications, right? Okay, right, the question solving approach, of this applications, right, and the relevant PYQs, and how this PYQs can easily be solved using this question solving approach, right? How this PYQs we are going to solve easily using this approach, right? So this is the second part of the flowchart for the units and measurement. Now let's move on to the most important part, errors, right? Right, in errors we are going to discuss errors for one physical quantity, right, combination of errors, types of errors, right, and some of the out of the box topics, like how errors we are going to discuss, right? Okay, how differentiation concept it is used in errors, because in JEE this kind of examples always, right? Okay, in JEE advanced, right, this kind of the examples are, right, always asked. Okay, but we are going to see the glimpse of this only, right? We are not going to see what we can say that much detail approach, because this concept is completely for the advanced level, right? Okay, but I'm going to give you the short explanation, right, and the short simple approach for this. Okay, apart from errors, right, we are having, right, the Vernier caliper, or in another sense we can say directly the measuring instruments, right? Okay, the measuring instruments, right? Okay, measuring instruments. And for this measuring instruments, right, we are having the two things: Vernier caliper, right, and second, micrometer screw gauge. Right. So this is what the flowchart of the units and measurement is, right? Okay, this is the flowchart of the units and measurement. So, right, I'm moving aside. If anyone wants to take a snap, just pause the video, right, and have a screenshot for it. Okay, guys. So I've moved aside. Okay, so I'm giving you all of 5 seconds, right? This is a flowchart of units and measurement. So 5 seconds to all. Okay, and countdown starts. 5, 4, 3, 2, 1, and that's it. Right. Okay. So now let's move forward to the most important part. Lots of visualizations are going to come, right? Because this is the first chapter, right? And we have to deal with the very basics of it, right? This is the first chapter and we need to deal with the basics of it. As I said, right? Okay, thousands, right? In this entire series, thousands of examples, right? They are going to come. And obviously they will be from your day-to-day life. Why? See, when physics is hard, when it is represented, but when physics is easy in front of you all, right, when it is represented well, right, if I'll act like a teacher in front of you all, then obviously physics is going to be hard for you. But if I'm going to up to your level, right, if I'm analyzing, right, and like I'm behaving like as you are, and I'm teaching in front of you all, right, then that will be what we can say the new temperament will be created in this lecture. Yeah. So right now the things are not going on in between you and me, right? That right now the things are going on between, like, one friend is explaining to another. You can call me as a mentor, right? Please don't call me sir, something like that. Because in our previous video, I've seen all of those relevant comments. Sir this and sir this and sir. You can call me, right, brother, bhaiya, right? Okay. Okay. You can call me by those sir. It's like, it's okay. It happens, right? Okay. Okay. Because I want to move up to your level. I want to be like you and I want to explain physics in front of you all, right? Okay. So now, physics. Before moving on, see, physics, I need to change the cover of the book, right? Because that is quite horrible. Okay. And seeing that cover, maximum number of the students, right, leave from the front gate only, right? They never used to enter the mansion. Why? The mansion seems haunted. Whoa, the book of the cover is quite horrible. No, I don't want to enter this mansion. Let's leave from the gate. Now, among them, 5 to 7%, yeah, this mansion is quite horrible and we need to, right, we need to be quite adventurous, right? So that kind of the psychology is always there. So what is physics? What is physics? So right now, many questions will come up in front, sir. Why you are giving this kind of the explanation in crash course? What kind of the nonsense thing is going on? Right, sir? Now, what is physics? Is a subject. Yes, it is a subject. It is a very crucial subject, right? Okay. Someone did something in physics and we are facing his karma, right? Someone did immense thing in his physics, right? According to the law of karma, he should face that stuff. But he did and we are facing. So what kind of this karma is going on? Physics is a subject, right? A non-fruitful subject. We are not going to understand all of those concepts in this future, right? Nothing is going to come, right? Because we are going to earn money in future, right? Right? So nothing of this stuff, right? It is going to come and help it out, right? In increasing our bank balance. What the hell? Physics. Physics is nothing, right? Okay. So see, physics. Okay. I want to begin with a story. Okay. Suppose let us take an example, right? Okay. I'm standing here. Thanos is standing in front of me, right? Please. See, example is what we can say quite simple. You have to imagine, right? But most, like, lots of important stuffs are going to come from this specific part. Lots of important stuffs. right? You just imagine, right? Like a Thor, you have to just imagine you are having a hammer in your hand, right? Your own created hammer, right? And you just pierce that hammer into the chest of the Thanos. He is in front, and he told, instead of this chest, you have to just pierce into the head, and he snapped. This is the story, right? This is the story. Now something is happening in my surrounding. One activity is going on in my surrounding, right? One activity is going on in my, something is happening in my surrounding, right? What was the step? Thanos snapped. Half of the universe disappeared. Half of the universe disappeared. No, but I'm still here. So yeah, who's the observer? You. So whatever the concepts, whatever the theories of 11th and 12th that are kept in front of you all, right? Who is going to observe you all? You are the observer, because you are going to see, I'm going to represent, right? I will act like a journal, I will act like a book, I will act like a learning resource in front of you all. Who is going to observe all of the stuff? You. What you observed right now? Dash. One activity going on. Half of the universe is disappearing. The activity is going on. You are analyzing. Oh, half of the universe. Oh shit, man. The Winter Soldier went away. Whoa. Hey, Chadwick Boseman, the Black Panther, is gone. Oh man. Half of the universe is getting. The Spider-Man is gone. The Doctor Strange. Oh shit. So you are the observer, right? The phenomena is observed, like going on in front of you. You are observing that stuff, right? Okay. So first important thing. Physics is all about, right? Physics is all about analyzing or studying whatever the activities are going on in surrounding. Whatever amount of the activities, right? I just helped out, yeah, to imagine one story, right? One situation. Like this way, Newton imagined once why it fell down. He imagined, right? He did the karma. Why it fell down? Calculus, gravity, etc., 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 etc. He gave all of those stuff, and oh man, why that apple didn't fall down? In that century, full apple. In this century, half apple, right? In that century, full apple. In this century, half apple. They have destroyed everyone. Okay. So physics is all about whatever the analyses are going on. Who is analyzing all of those stuff, right? Who is analyzing all of those stuff? Obviously one observer. Who is the observer? Student. One question is appearing in front of you all in examination. Then who is an observer? You. You are analyzing the question. You are keeping yourself in that specific part as an observer. Inertial, non-inertial, right? It is a different part. But you are analyzing something. You are an observer. So physics is all study about surrounding. We are not moving on to that much technical definition, right? Lots of technical definitions are given into the many books, right? But right now physics, right, into moving, rather than to moving on into the technicalities, right, we need to, right, be into the deeps, right? We need to be into the, right, the deep roots, right, of a tree to understand the concepts and fundamental things very well, right? And entire physics depends on two: why and suppose. See, whenever you are coming up in my lecture, now just keep one thing in your mind: why, suppose. Why, suppose. Why this happened? Suppose, right, apple fell, right? Let us again the same example we imagined before, right? Snap it. Half of the universe. Why half of the universe is getting disappeared? Logic behind it. Logic. Why half of the universe is getting disappeared? Because Thanos snapped. So because Thanos snapped, that is the reason. Who is observing? You are the observer. Who is finding the logic behind the activities that is going on in surrounding you? You are the person. Sir, we don't want to understand all of those stuff. Why you are wasting time? This is important because we are creating a foundation, right? We are not directly reaching up to the 30th story, right? Okay, we are not creating the third. We are not reaching up to the top of the building, right? We are building up the foundation, and it takes some amount of the time. right? So you all are right now completely aware of what is this. You are the observer, right? Something is going on into the surrounding, you are analyzing, and you are always till end of this series you have to ask two things. Why? Suppose. Why this is going on? Suppose half of the universe wouldn't get disappeared, then what will happen? Suppose the remaining persons, right, from this catastrophic events, right, what they are going to do? Are they going to create the new universe? All of those possibilities, right? So physics is all about this stuff, right? Snap. This kind of the awesome visualizations and examples are going to come in front. Okay, now physical quantity, same example, right? Okay, I'm going to take only one single example and we are going to study lots of stuff here, really practical. Okay, same example. What? Half of the universe is getting disappeared. Oh man, the most important superheroes went on. Hulk also, yeah, Hulk was my favorite. Yeah, that's not fair. Why he is getting disappeared, right? Okay, that specific organization who is creating all of those stuff is brutal. Nonsense. Hulk was my favorite. I can understand in last of 2 to 3 pictures he was not performing well. What I was expecting like Hulkbuster, but no, he was not performing well. But it's okay. Still, he is my favorite. But he disappeared. Now, what is this physical quantity? Right? You are analyzing this stuff. Okay, let us take another example. Right? Okay. I was ideally sitting in my room. It was a holiday and I was just playing with half of my apple. Right? The mobile phone I'm talking about. Right? Suddenly my mom came into the room. Oh, I'm in the need of the, what we can say, the tomatoes or any kind of the household stuff. You need to immediately move on to the supermarket, buy those because lots of guests are going to come in the evening. What will be your reaction? See what situation is going on, activities is going on. The mom came, he ordered you, right? And you have to do on the day of the holiday. This is a scenario, right? Who is the observer? You are the observer. Mom is coming in front of the activity is going on. You are analyzing this stuff. Now, suddenly you responded because you are having two questions in your mind. Why mom asked me? Because she is like having some missing items in her home, right? And I need to fulfill. Why? So I give the reason. Suppose if I'm answering no, mama, tash. Oh, mom, you hit me hard. That's not fair, right? So I've answered both of this stuff. Why? Suppose. Why I want to buy that stuff from the supermarket? Guests are going to come and we are having the missing items in our home. Suppose if I say no, sat. Oh shit, man, I need to move on. So what is a physical quantity? One factor that describes the phenomena. What kind of the phenomena is going on? Mom slapped. What was the intensity? Oh man, sir, we never calculate the intensity. In thousands of times we used to get slapped at the home. Right, it's our regular routine and we never measure that intensity. One factor, right, that is measured. There was slap with what intensity? Sat. What intensity? So that factor that describes the phenomena going on in surrounding. Right? So I can define the physical quantity as factors, right, measured by an instrument, right, factors measured by an instrument that describes the, right, that describes the laws of nature. Okay, I'm sorry. Okay, that describes laws of nature. Either laws of nature, because physics is all study about of all of the stuff only, right? But with the advancements into the field of science and technology, right, we are also analyzing all of those artificial stuff also, right? So in another sense, rather than to describe as a laws of nature, we are simply describing it as an activity. We are simply describing it as an activity. So what is the physical quantity? See, you can just understand the flow. What is the physics? Analyzing the stuff, analyzing the activities which is going on in my surrounding. Now, how I want to represent this thing? Suppose if I am speaking you in front of you all, right? Then how I want to represent this lecture, right? Okay, in terms of notes, right? We are uploaded one link into the description and that note has been forwarded and been shared with you all. So you can have the whatever the write-up of an entire lecture in just the one PDF form, right? So the same way, analyzing this activity is going on. It is a study of physics, right? But how I want to represent that stuff, right? Okay, what are the factors involved in that example? That is a physical quantity. The measurement of all of those factors, right, by an instrument that describes one activity going on in surrounding, that is a physical quantity. So first, physics, physical quantity. Physics, physical quantity. Now we are moving on to the next part, units. The same example we are going to take in front, right? Units. Holiday, sitting, busy with half apple. Mom came, you have to buy this stuff from the supermarket. Why? Because guests are going to come. Suppose if I say no, results are, right, already been observed and been noted, right? Results are already observed and been noted. Okay? But mom slapped. I told you, intensity. It has been measured. How much? Suppose let us take an example. Mom like told you to buy some amount of the vegetables, right? Some amount of the vegetables you have to buy from the supermarket, right? Okay, so this activity is going on. You are analyzing, you are roaming into the supermarket. Hello, how are you? You've met your friends, your near and dear ones. Okay, you went near to the vendor, right? The area where the vegetables, fresh vegetables were kept, and say, I want 2 kgs of potato. So how you measured? You need things for measurement, na? Mom slapped. With what intensity it was slapped? Intensity. That is a physical quantity. But how intensity is measured? In what terms it is measured is unit. Physics, physical quantities, units. Right? Okay. So apart from this, yes. Classifications of the physical quantities, right? The first one, if I'm talking about the physical quantity, right, then it is classified into the 2 types. Again, I'm going to ask you all why and suppose, right? Physical quantities, right? Slowly from the basic, we are going to, first of all, we are going to build the foundation, right? After that, we are going to create a, what we can say, the common parking, and slowly, first floor, second floor, and obviously at the end of this lecture, we are going to create one penthouse at the top, right? With an awesome sea view. Okay, slowly. But just one thing I need to guarantee you all: you need to you need to stay till end of this lecture, and really you're going to enjoy this stuff. So physical quantities. First one, that is a fundamental physical quantity. Second one, that is a derived. Right. Third one is a supplementary. Physical quantities. Why? Why this fundamental? Why this derived? Why this supplementary? Right? Can't we have the common thing in front of you all? Why they have been classified? Why? As I said, physics is all about why and suppose. Why it has been done. So this is a classification. Now let's move on to the most important part of this chapter. Right? Okay. As you have seen into the beginning of this lecture, right? There are the 7 fundamental physical quantities. Right? There are 7 fundamental physical quantities. Okay. There are 7 fundamental physical quantities, right? They are not basics, they are essential. Why they are called as fundamental physical quantities? Because why this kind of the classification is there in front? Because in the universe, without these physical quantities, none of the phenomena is possible. If you want to describe any laws in nature, right, you need one factor. Without this 7 fundamental physical quantities, we are not able to describe any of the phenomena that is going on in universe. That's why they hold the special prominent position in physics, and that's why they are defined as fundamental physical quantities, right? So simple, without moving on. See, lots of definitions in thousands of resources are there, right? I'm keeping that definition that is very easy for you, that is easily understood by you, right? The same stuff I'm keeping in front of you all, right? Okay, so rather moving on to that much amount of the technicalities, right? Simple, fundamental. Without this, we can't analyze any phenomena. Without this, right, I can't analyze. Suppose I'm talking about the weird example. Ideally sitting with my iPhone. Weird example, right? That has no sense from the physics point of view. But still, mass is stationary. Mass is there. If I'm talking of a small point-like object, still mass is there, right? If I'm talking about the weird phenomena of the physics, then also the without fundamental physical quantity, I'm not able to describe that. So basically there are 7 fundamental physical quantities. First one is mass, right? Second one is length, right? Third one is time, right? Electric current, okay? Amount of substance. I'm extremely sorry for that because okay, I'm extremely sorry. I think we are not able to, okay, because it should be in sequence. It's okay. Amount of substance, electric current, thermodynamic temperature, and luminous intensity. This should be in sequence, but it's okay, right? Luminous intensity, right? Luminous intensity. Okay, as of this high visual, this kind of the, what we can say, the lag has been generated in writing. Okay, so these fundamental physical quantities are essentials, right? Apart from being basics, they are essential. Okay, now moving forward to the next part. As I said, without these physical quantities, we are not able to identify, or we are not able to, what we can say, define any process. But see, when it started, it was all about the fundamental physical quantities. Now we are growing. We are growing high, right? So we analyze some phenomena. Apart from this, right, there was involvement of some another factors also. Same example I'm going to take. I was sitting ideally, mom came, right? Same example. Okay, mom slapped. What intensity? How much amount of the force was applied? How much amount of the force that was acting per unit cross-sectional area, right? What was the reaction? Ouch. Mom, you hit me hard, right? Okay. So apart from this, what was the mass of the hand, right? What was the spatial area up to which effect was generated as because of hand, right? Okay. So lots of terms are there. So what is the derived physical quantities? Right? We can say the combination of more than one fundamental physical quantity, more than one fundamental physical quantity. Combination of more than one fundamental physical quantity, right? Okay, and here comes it is defined as derived. Now, what are the example of derived? Force, right? Why? It is mass into acceleration, and obviously mass into distance by time ka square. Momentum, mass into velocity. Momentum is a derived quantity, so it can be defined as, right, mass into, right, x by time. Okay, force, momentum, torque, work, intensity, right, acceleration, velocity. This all are the examples of the derived quantities. If there are fundamental physical quantities, then we are having the fundamental units. If there are the derived quantities, then we are having the derived units. Right? If I'm talking about the fundamental physical quantities, right, then there are 7. Then they are having the relevant units. Mass, it is measured in kg, like all of those stuff you are completely aware of. Right? Now, like for derived quantities, we are having the derived units. Right? For derived quantities, right, we are having some derived units. Now, let's move on to the next part. Okay? Okay, come on, yaar. Okay, this thing is taking some time. Okay, now, okay. With advancement, see, you can just understand the flow of this chapter: physics, why and suppose, physical quantities, and then we moved on to the units, and then classification of the physical quantities. We classified the physical quantities in 3 types: fundamental, supplementary, and this one, derived. So we moved on to the fundamentals. Without them in universe no phenomena is possible, right? Okay, rather than to moving on to the technicalities, right, we understood that definition that was appropriate for us and that can help us to understand those concepts. After that, we moved on to the specific part of what? Derived. It is a combination of more than one fundamental physical quantities, right? We gave some example. Now supplementary. Why there was a need of a third classification? It was a very important thing, right? Why there was a need of a third classification? Yaar, 2 were appropriate, right? 2 were appropriate. Then why they kept this third, right? And why the plane angle and solid angle were defined, right? So let's move on to the stuff. Okay, supplementary physical quantities. Okay, see what it states: supplementary physical quantity. See, some of the phenomena in universe exists in which, right, these 2 physical quantities holds the prominent position, but it doesn't mean without this phenomena in universe is possible. Again, I'm repeating, right, taking the same example. I was sitting in front with my iPhone. Mom suddenly came. She slapped. I was the observer, physics. I was analyzing the phenomena. I was studying physics, right? Lots of physical quantities came, but at what angle mom slapped me? Patak! At what angle she kicked me? So, mom never used to kick, right? Especially us. No, that's not possible. I can understand that's not possible, but. Right, is it possible? At what angle things are going on with the observer's point of view, right? So it doesn't mean, see, without this physical quantity in universe, phenomena is possible, but there exists maximum. There exist all phenomena without fundamental physical quantities. It is not possible to define all phenomena of physics. But for supplementary quantities, it is not possible to define maximum number. See, you can understand the difference. For fundamental physical quantities, whole phenomena. For supplementary physical quantities, for maximum number of phenomena. So it doesn't mean without this phenomena is not possible. It is possible, right? But maximum number of the phenomena without this quantities is not possible, right? So rather move on to the, right? That's why they are named as supplementary, right? Maximum number phenomena not possible without this. Maximum number of the phenomena are not possible without this, right? Maximum number of phenomena are not possible without this, right? I think it's because of the high visualizations, right? Okay, this thing is going on, right? So for that, supplementary physical quantities, we are having the 2 things. The first one, that is a plane angle, right? Okay, and second one, that is a solid angle, right? Okay, rapidly we are going to discuss this stuff, and okay, we are going to reach the concepts of the dimensional formulas, right? Okay, now see, plane angle. I gave you example in front at what angle mom hit me up. Yeah, let's imagine one situation, war is going on here, you are having Ghoda Banduk in front. Okay, Ghoda is not a properly word, right? But war is going on and there are lots of tanks nearby. From the level ground surface, at what angle tank is firing a ball? We have seen the periodic films, right? Okay. Then what we can say, the lots of cannonballs are there. Na? Have you seen Mughal Azam? Right? Zindabad, Zindabad, Mohabbat, Zindabad. You have seen Mughal Azam, na? You have seen Jodha Akbar, lots of, right? Okay. If you have seen Troy, right? Okay. You have seen King Arthur, this kind of the movies, right? If you have seen, right, then lots of cannonballs has been used in wars, right? Okay, in Troy, and you can see in this kind of the period films, right? Spartans, obviously I haven't seen in Spartans, but I'm giving you just one of the examples, right? So with respect to the ground, with respect to the horizontal surface level, at what angle, right, the nozzle is tilted? You can see at what angle the nozzle is tilted. So what is the definition of the plane angle? Angle subtended by a radius. Angle subtended by a radius, right? So one example is there in front of you all. More specifically, right, it is angle subtended by an arc, right? Okay, angle subtended by an arc. Okay, radius is forming that arc, it's not a big deal, but general definition, if you are moving on, it is one of the, right, an example. Okay, like let us take an example. Suppose this is point A, right, and this is a center point O, right? Suppose this is a radius and it is forming one arc like this way. So this is the solid angle, right? Okay, angle subtended by an arc, right? Okay, so what is the formula of the, it is a kind of the 2D angle, right? The unit is radian, right? Unit is radian. Okay, unit is radian, and secondly, what will be the formula? Theta, that is equivalent to arc upon radius, right? Okay, this is the simple definition of the plane angle. At what angle, mom, hit me up with respect to the horizontal level, right? That will be my plane angle. Now, what will be the solid angle, right? See, if I'm talking about the solid angle, right, the most important stuff, it is a, first of all I want to tell, it is a 3D angle, right? It is the 3D angle. Now what kind of the 3D angle, how we can correlate this concept of the solid angle to the day-to-day life, right? I'm giving you all one simple example in front. Have you ever moved on to the right, have you ever, right, move on to buy watermelons? So why I kept this example in front? Why I kept this example? See, whenever we used to buy the watermelon, we are always having one doubt, right? We will get what we can say the sweetest watermelon into the minimum amount of the price. That is an Indian psychology. We need the sweetest watermelon into the minimum amount of the price, with lots of bargaining. So at that time, to clear our doubt, right, whatever you all, what we used to ask a vendor. See, this is a day-to-day life example that is going on in front, right? A very common example, and this activity or this thing you have experienced thousands of times in your day-to-day life, right? To clear our doubt whether that this fruit is what we can say sweet or not, what we used to say, sir. First of all, we never used to say sir, we used to say uncle. Just cut that specific part and show us, right, whether we are buying a right watermelon or not. So what do you, the what we can say, how the vendor is going to respond, right? He used to take a knife. Okay, he takes his knife and cut. So see how awesome this watermelon is, right? Okay, so he just slice out one small part. right? Okay, that defines the solid angle. Suppose, let us take a very simple example. This is a sliced part that has been cut from the watermelon, right? This is the sliced part, right, that has been cut from the watermelon. Okay, this is the sliced part that has been cut from the watermelon. You can imagine this situation now with respect to this center point O, right? Okay. Now, what will be the solid angle, right? The solid angle, it is a kind of, first of all, I want to define it as a 3D angle, right? Generally, it is formed in cone-like structures, right? Generally, it is formed into the cone-like structures, right? Okay, cone-like structures. Generally, it is formed, right? Suppose, let us take another example to understand this situation very well, right? Let us take another example to understand this situation. Yeah, today I think it's because of lots of visualizations, right? Okay, the presentation is supporting less. Okay, no worries. Suppose if I'm talking about this area, can I say this is the area A of slice and this is the radius R, right? Okay, if I'm talking about a very small area element of it, if I'm talking about the very small, right, area element of it, right, like this way, a very small area element. So this area element is defined as dA, right? It is extending from 0 to A. This dA element, it is, right, first of all, it is shrinking to 0 and obviously it is, right, expanding to A. So it ranges from 0 to A, right? And this is R. So solid angle, this is defined as a solid angle, that is by R square, dA by R square, right? It is a kind of the 3D angle that has been formed into the conical like structures, right? And the most important note regarding this, right, most important note, there is one, what we can say, the conversion, right? There is one relation between the plane angle, or in another sense, the semi-vertex angle, right, and solid angle, right, that has been formed in cones, right? There is one relation between the semi-vertex angle, right? Now, what is that relation? Again, the same slice I am taking off, right? Okay, okay, here once solid angle is formed and here there is one semi-vertex angle is formed. See, alpha is the semi-vertex angle, right? Alpha is semi-vertex angle, sorry, semi-vertex angle, and omega is solid angle. Now, what is the relation between this solid angle and this semi-vertex angle, right? So that has been defined as phi, that is equal to 2 pi 1 minus cos of alpha, right? Okay, generally this kind of this stuff, right, they are used in, okay, electrostatics and magnetism, right? This formula is quite important and it is quite helpful also, right? Because at that point, right, okay, whenever we are defining the magnetic field lines and electric field lines, so this kind of the question based on this equation and already been asked into our previous years, right? Okay, so this is, if you want to snap it, this is a black screen, right? You're not going to get this stuff into the notes, right? So if you want to snap it, you can just snap it, right? I'm giving you the, what we can say, on the countdown of 5, I'm going to change the slide. 5 4 3 sorry 5 4 3 2 1. Now, so this was a solid angle. Obviously the unit is steradian. It is a kind of the 3D angle, right, generally formed in the conical like structures or 3D structures, right? Okay, now let's move on to see how you can understand this flow of the chapter. Now, physics, physical quantities, classification, units, right? Slowly we moved on to the supplementaries, right? Now, what are the dimensions? Now we are moving forward to the most important part, that is dimensions and dimensional formulas, right? After that, we are going to see some of the most important concepts related to the homogeneity, right? The analysis, the applications of the dimensional analysis and the relevant sums. But first of all, what are dimensions, right? What are dimensions? See, first of all, I want to tell you all, if I'm talking about the 7 fundamental physical quantities, mass, length, okay, time, temperature, current, mass, length, time, amount of substance, luminous intensity. Mass, length, time, temperature, right? Okay, current, amount of substance, and luminous intensity. See, we are having the 7 fundamental physical quantities. For this 7 fundamental physical quantities, obviously we need one notation. That notation is not dimensions. Dimension is something else. But to understand that definition very well, right, we are in need of the notations for this fundamental physical quantities. We are in need of this notation for the fundamental physical quantities. See, if I want to represent the mass, and obviously say, taking the same example, you went to the supermarket, you asked something, you asked in kgs. Kg is the unit of mass and it is represented as m. Right? Length. Generally, we are measuring the length as meter. Right? Okay, somewhere it has been measured in feet. Right, somewhere in centimeter, right, somewhere lots of datas are there, but this is a general notation of, right, representing length. Time, we are representing it as a t. Temperature, we are representing it as a either k, right, or somewhere it has been represented as theta. Current, we are representing as an ampere. Amount of substance, we are representing it as a mole, right, and candela as cd. Power to any physical quantity shows its dimensions. Power of fundamental physical quantities. F.P.Q, that stands for fundamental physical quantities. The powers of fundamental physical quantity, right, that describes its dimensions. Powers. Sir, you wrote down this definition, but this time your example was not as much fruitful as what we did into the previous part. So let's understand this stuff. See, suppose let us take an example. I'm giving an example in front of you all for the time. Now, what are dimensions? I just wrote down power to the fundamental physical quantities. These are the dimensions, right? Power to fundamental physical quantities, right? Those are dimensions. But let's take a very simple example. Okay, let's take a help of a black screen to understand this stuff, right? Okay, see, suppose if I'm talking about force, right? That is mass into acceleration. Right, if I'm talking about an acceleration, see, it is velocity by time. If I'm talking about the velocity, this is mass into distance by time square. How I can symbolically represent mass as m1? What is the power 1? How I can represent the distance L? What is the power 1? How can represent the time t? What is the power -2? So what are these dimensions? Right, what are the dimensions? See, whatever these powers they are assigned now, right, these are the dimensions. Generally, they are assigned to the fundamental physical quantities, but depending on the application, right? Okay, but that part will come into the dimensional analysis. Sometimes it has been also assigned to the derived also, right? Okay, but that we will see into the dimensions. The general definition states whatever these powers they are assigned to the, right, the fundamental physical quantities, they are their dimensions, right? Okay, so this is one example I kept you all in front. Okay, see, so dimensions, as I said, right? Okay, powers, mass, it is represented by m. According to the derived, whatever the phenomena it is going on in surrounding, right? Is it not important, right? It is not fixed, right? It is not what we can say fixed, that mass will be only 1. The dimensions of mass will be 1. No, it is not fixed, right? So that's why these are the symbolic notations, right? Okay, these are the symbolic notations, and the powers of this fundamental physical quantities are dimensions. Now, moving on to the next part, what is a dimensional formula? See, you can understand this flow, how we had built that foundation, why, suppose, and slowly, right? And after this, we are going to see on to the principle of homogeneity. right? The dimensional analysis part is going to start. After that, error analysis is going to start. After that, Vernier Calliper and Micrometer Screw gauge, and we're going to end this lecture. Now, dimensional formula. What is the dimensional formula? Representation of all physical quantities. The representation of all physical quantities, right? In terms of basic notations that M, L, T, A, K, mole, CD, right? That representation is a dimensional formula. The representation of all the derived quantities present, right? The representation of all the derived quantities that is present, right? Okay, in terms of this, all of this basic notations, right? That is the dimensional formula. Now let us take an example for that first. Acceleration. Acceleration is defined as velocity by time, and that is distance by time square. What is the notation we are using for distance? Distance is a kind of a length. Now we are using L. Mass is not present, so it means power of m will be 0. Dimensions of m will be 0. L in the numerator, that's why it is 1. Time is in square, right? But it is in denominator, so that's why we are writing it as a -2. Right, so this is what we can say the representation of acceleration in terms of the acceleration is a derived quantity, na? So this is what were representation of acceleration in terms of the fundamental physical quantities, and that is a dimensional formula. See, lots of technical definitions are there, right? Lots of stuff is present in the law, ample amount of the many resources it is present, but I'm not interested. I always used to keep these things, right? Whatever it is helpful to understand. Right, in the way it is what we can say quite helpful to understand the physics stuff, the things I'm keeping in front. Second example, if I'm talking about, right, okay, let us take an example, work, right? Work is force into displacement. Force, it is mass into acceleration into displacement. Acceleration is distance by time square into distance, so it is md square by t square. Now, what are the dimensional formula for work, right? What is the dimensional formula for work, right? So, can I remember for mass, I'm writing it as m1, power is 1. For length, I'm writing it as L2. Time is in the denominator, so it is m1 L2t minus 2. This is for work. So, students at this point of time, they are having one complex view, how to remember all of those dimensional formulas, right? It is quite difficult for us. Right, it is quite difficult for us how to represent, how to remember all of those stuff, right? So in that case, right, I'm going to tell you all in front, rather than to, right, remember all of those stuff, just remember the units. Let us take an example, right? If I'm talking about the kinetic energy, right, if I'm talking about the kinetic energy, obviously it is equal to half mv square. What is the unit? Can I say it is kg meter square per second square, right? Using this unit, right, I'm going to represent the dimensional formula m1 L2t minus 2, right? How to represent the power? Power is work done per unit time. You are aware of the dimensional formula of work done. That is m1 L2t minus 2 whole divided by, right, t. So what will be the dimensional formula of power? The representation of the, right, power in terms of fundamental physical quantities is this, right? You have seen this formula, F is equal to G m1 m2 whole divided by r square. What is the dimensional formula of G? Where G stands for gravitational constant. Where G stands for gravitational constant. F is equal to G m1 m2 whole divided by r square. So can I say G that is equivalent to F dot r square whole divided by m1 m2. Right, what is the dimensional formula of force? m1 L1t minus 2 L2 whole divided by, right, m2, right? So what is the dimensional formula G? It will be m minus 1, right, L3t minus 2. This is the representation of the gravitational constant, right, in terms of fundamental physical quantities, and that's its dimensional formula. So rather than to move on, right, remembering all of those stuff, we have to see, okay, in one film, 3 Idiots, सक्सेस के मत पीछे भागो, काबिलियत के पीछे भागो, डायमेंशनल फॉर्मूला के पीछे मत भागो, यूनिट के पीछे भागो. Same thing we are going to, right, apply here. Okay, we have to just remember all of those units, right, and dimensional formulas will be in front of you all. Okay, now let's move on to the very rapidly we are going to see the examples. What are the dimensions of stress? See, this question has been asked in NEET 2020. Short. Dimensions of stress. Dimension formula of stress. SAR. 4 marks with us. Right? So let's move on to the, okay, see. First of all, I'm moving aside. If you want to pause the video, okay, just pause the video, right? You can solve it, because in our previous session, right? Okay, in our previous session, right, I always used to give 1 minute to solve this stuff, but many questions, many students told us that this is not a live lecture. We can even pause the video. At that time, I gave the explanation, right? At that time, I gave the explanation. Yeah, I want you all to solve with me into the 1 minute amount of the time. Why? Because that thing will help you out, right, in interacting with me, right, like with the convenient interaction with me, right, and that will increase the speed, accuracy, and the command over the subject, right? So dimensions of the stress. Okay, stress, what is defined? Stress, how it is defined? That is force per unit area. If you are aware of the dimensional formula of force, then it's okay, right? See, suppose if I'm directly writing is dimensional formula of force is m1 l1 t minus 2. Dimensional formula of area is l2. So this is m1 l minus 1 t minus 2. Is a perfect. So this is the dimensional formula of stress, that is m1 l minus 1 t minus 2. m1 l minus 1 t minus 2. Right, for this, right, okay, 4 marks. The pair of the quantities having the same dimensions. Karnataka, NEET 2013. Oh, sir, from units and measurement, right? Why you wasted the, what, how much amount of the time? Oh man, 1 hour has been completed. Push. Okay, no worries. No worries, no worries. Right? You wasted, sir, 1 hour. I didn't waste it. I built your foundation, right, in physics. Because from after seeing this lecture, those who have seen this, right, okay, now this thing is going to change the scenario of physics in front of you all. From now onwards, you are going to say why, suppose, you are being an observer and you will analyze the each and every theory, right, of the syllabus of 11th and 12th of JEE and NEET, right? So now this has been asked in Karnataka NEET 2030. Okay, impulse and surface tension. See, impulse, if I'm talking about the impulse, then that is force into time, or in another sense, mass into change in velocity. The momentum is impulse. This force per unit length. Can you see this physical quantity? See, if I'm talking about the impulse, then dimensional formula of impulse is m1, right, l1 t minus 1, right? Okay, this is the dimensional formula of impulse, right? But if I'm talking about the surface tension, then it is force per unit length, that is m1 l1 t minus 2 whole divided by l1. The dimensional formula of surface tension is m1 l0 t minus 2. These two dimensional formulas are not equal. A is, we are going to get cancelled. Angular momentum and work. Torque, that is change in angular momentum by change in time. Dimensions of torque, that is equivalent to dimensions of work. Dimensions of torque, that is equivalent to dimensions of work. So it means that if it is change in angular momentum with respect to time, then how these two things are going to be equal? Wrong. Work and torque, yes, obviously. Work, that is equal to force into displacement. Torque, that is equal to perpendicular distance into the force. Both are having the same dimensional formula, m1 l2 t minus 2, right? Torque, we are having m1 l2 t minus 2, right? C is the perfect answer for this specific question. Dimensions, this thing you can solve, right? You can just try, okay? and write down the answers beneath the video, right? It's based on the direct formula. Yeah, you can easily solve it. Now, because principle of homogeneity, sir, here we are going to begin the dimensional analysis part, right? Directly we are going to, right, directly we are moving forward to the most important, the applications of the dimensional analysis. 3 applications in next 40 minutes with relevant PYQs. We are going to discuss the 3 important definitions of this. Right, in the next 40 minutes with the relevant PYQs, we are going to discuss the 3 most important applications of the dimensional analysis. From this, right, see, dimensional analysis is going to start. Right, basically left LHS, RHS, validity, dimensional analysis, equations, validity, all of this stuff, right, up to the boards level you have studied. But I'm talking about the dimensional analysis, then obviously principle of homogeneity we are going to discuss, right, into the very funny way, right, as you have seen. Second, conversions we are going to discuss, and relations between the physical quantities, right? These 3 things we are going to discuss right now with the relevant PYQs, right, with the relevant PYQs. This is a part of the dimensional analysis, right, with the relevant PYQs. Okay, so are you all ready? Are you all ready? So let's move on to the most important part, right? And see, we are going to deal this stuff into the most funny way, right? Okay, we are going to deal this stuff into the most funny way, right? Okay, now see, what does it states? What does the principle of homogeneity states, right? 2 example I'm keeping you all in front, right? 2 most important example, right? Those are the part of the day-to-day life also, right? Funny also, right? And this will help us, right? Okay, to understand the question solving approach of this topic and the fundamentals of this topic into the most convenient manner. Now, see, first of all, principle of homogeneity states that if the equation is dimensionally valid, right, then LHS, right, okay, of the equation is equivalent to RHS, right? I'm talking dimensionally. See, we are having one star, terms and conditions, right? Star. We are talking dimensionally, not mathematically, right? Lots of phase you are going to write phase, lots of phase, PHASE, right? You're going to phase, FACE, right? In this, by solving this sums, right, related to this topic, in which, right, lots of doubts will arise that those equations are not mathematically valid. Then why? Like, mathematically, at some point of time, mathematically, some things are not valid. So that's why in the beginning of this topic only, right, I'm telling you all that we are going to see this stuff dimensionally, right? We are going to see this stuff dimensionally, not mathematically, right? All of the things. If I have written LHS and is equal to RHS, so I have written, right, dimensionally this is valid. Suppose let us take an example. If I'm writing the equation S is equal to U of T plus half AT square, F is equal to MA. So suppose F is equal to MA I have written. So F is an LHS, the product of MA, that is RHS. So LHS is equal to RHS is dimensionally valid. Mathematically we are writing F is directly proportional to M, or F is directly proportional to, right? Not in this case, we can write it dimensionally as a direct relation, but one physical quantity, right? Okay, one physical quantity, right, as a right relation with another physical quantity. So for that we are using the proportionality relation. So LHS equal to RHS, that we are writing it as dimensionally. So what does the principle of homogeneity states? It states that whatever amount of the whatever the terms on the LHS is there, they have the same dimensions as of the terms that are present in RHS. Terms in LHS that are having the same dimensions as term into the RHS, right? Okay, this is what the principle of homogeneity states. Now, what, see, why I kept this example in front, right? Okay, why this? Okay, if you've seen this movie, right, there is one dialogue, जो तेरा है, मतलब जो कल तेरा था आज मेरा है, कल किसी और का हो जाएगा, ढूंढू, just chill, right? जो तेरा है, you've seen the ad, जो तेरा है वो मेरा है. The things on the left side, that is equivalent to things on the right side. Principle of homogeneity, right? Sometimes rather than explaining things, right, we can capture one visual and be silent, because in some of the cases, right, silence speaks louder than words. As you all are aware, principle of homogeneity, silence is speaking louder than words, right? Again, I'm repeating with a small right, a cunning smile on my face, right? Principle of homogeneity is silence speaks louder than words. Principle of homogeneity, silence speaks louder than words, right? And the second example, कल तेरा था आज मेरा है, परसों किसी और का हो जाएगा, ऐसा कहीं लिखा है, don't do, just chill. So that states a principle of homogeneity. Apart from this, there are 3 to 4 noteworthy points, right? Okay, and those are quite important regarding the question point of view. So that those points we are going to include into the question solving approach. So first of all, I want to tell you all, is that principle of homogeneity clear into the mind? Whatever the terms on the LHS, technical definition, right? The most technical definition, whatever that is on the LHS, we are having the things on RHS. Dimensions on the LHS equivalent to RHS. Suppose if we are having this kind of the equation, then on the right hand side, we are having the two terms. So in this case, we can say LHS is equivalent to RHS of first part. Similarly, LHS that is equivalent to RHS of second part. LHS that is equivalent to RHS on the first part. LHS that is equivalent to RHS on the second part. Right? Not more than, right? See, dimensional analysis is also having some kind of limitations, right? But what we are not moving into the deepest of deep, right? We are not moving into that part right now. But LHS, RHS, this is a principle of homogeneity. Dimensions on the left side, it is equivalent to dimensions on the right side. Now, what will be the question solving approach for it? First, as I said, LHS that is equivalent to RHS, right? We are going to deal with the stuff dimensionally. We are going to deal with the stuff dimensionally. Third part, right? All, see, we are not going to steal mathematically all the sine and cos type of terms, right? All the logarithmic parts, all the e to the power parts, right? This all are dimensionless. The third most important point, right? First, LHS is equal to, see, these are some noteworthy points, right? First, LHS that is equal to RHS. Noteworthy points in another sense, how we are going to use these questions, or how we are going to use these points, right, in solving the PYQs. Yes, PYQs, it means the same thing that has been already asked into the previous year papers, right, of JEE and NEET. All things we are going to discuss it right now only. 4 points. The fourth point is, I'm writing here because it is okay, this two physical quantities can only be added or subtracted. Two physical quantities can only be added or subtracted if they are having same dimensions. So this is the fourth most point, a most important point, right? Okay, for the questions regarding this. First, LHS, RHS. Second, we are going to deal right things, okay, dimensionally. Third most important point, right? All the sine and this kind of the terms, log, e to the power, this all are dimensionless if the equation is dimensionally valid, right? And two physical quantities can only be added or subtracted if they are having same dimensions. Added or subtracted, either it is an algebraic addition, either, okay, it is a vector addition. Okay, so now Force will be added with force, velocity will be added with the velocity kind of the dimensions, right? Velocity can be added with velocity and that physical quantity who is having the same dimensions as the velocity, right? Okay. So this 4 noteworthy points are, if you want to take a screenshot of this, this is the real question solving approach, right? And we are going to use this stuff into the PYQs. See, let's see the question that was asked in JEE examination, okay, in April 2010 and 2016. 2016, right? See, most important thing, see. Okay, first of all, I'm giving you all a minute. Should I give you all? Okay, see, let's see. A, B, and C and D are the 4 different physical quantities having the different dimensions. None of them is a dimensionless. A, B, C, D, 4 physical quantities. Question asked in 2016. We are going to solve from the question solving approach, right? Okay, see how. Whatever we are studying right now, there are already this kind of thing. Okay, so that question solving approaches will be quite helpful. Right, with basics, this question solving approach is going to be quite helpful. Okay, A, B, C, D are the 4 physical quantities. They are having different dimensions. It means dimensions of A are not matching to B, neither to C, nor to D. Right? All of their, and none of them is dimensionless. Means all are having the dimensions that is compulsory. And even they are not dimensionless. They are having dimensions and not equal to each other. Right, they are having different dimensions. So which of the combination is a meaningful quantity? Among 4 options, which of the right is a meaningful quantity? So I think let's give you all a minute to solve this question, right? First of all, okay, this is, okay, solve this with me only, right? That will increase the speed, accuracy and command over the subject. Come on. Okay, so very simple thing. If A, B, and C and D all are having the different dimensions, if they all are having the different dimensions, it means that they can't be added or subtracted. Question solving approach point number 4. 2 physical quantities or more than 2 physical quantities can only be added or subtracted if they are having the same dimensions, right? If A, B, C and D, they all are having the different dimensions, then how we can add them? Product of A, D square by C. By evaluating this term, let us take an example, right? The D physical quantity is having some dimensions and we are making square of it, multiplying with the dimensions of A, right, and dividing by C, evaluating this term, there is a possibility that it may get equivalent to C by BD. So these are not the individual physical quantities, right? Some of the algebraic operations has been done. Some of the algebraic operations has been done. It means something of AD square by C is equivalent to, or you can say dimensions of AD square by C, that is equivalent to dimensions of C by BD. Dimensions of AD square by C, that is equivalent to dimensions of C by BD. That is possible. It might be possible. I can understand, right? Dimensions of A, B, C, D is not given, but there is a possibility for first question to be correct. B. There is a possibility A square might be equivalent to B square C square. Dimensionally, as I said, I'm not writing it mathematically, I'm writing it dimensionally. Dimensions of A square, right, that can be equivalent to B square C square, or A can be equivalent to product of BC. So this can also be meaningful. A by B, there is a possibility that A by B ratio, dimensions of A by B can be equivalent to C. But this thing is not valid because A and C, they both are having the different dimensions. Then how they are subtracted? If A and C, they are having the different dimensions, then how they are subtracted? And that's not good. This is violating the things, right? So here, this is not meaningful and D is a perfect answer for this specific question. Right? Okay. The fourth point, using this fourth point. Now, let's move on to the next PYQ. Okay. 11th January 2019 in the phase 1. The force of interaction between the two atoms is given by this equation. See, equation is F is equal to alpha of beta, right, e to the power, right, minus x square by alpha kt, right, where x is a distance, k is the Boltzmann constant, and t is in temperature, and alpha and beta are two constants. What will be the dimensions of beta? Interatomic forces are represented by one equation. Interatomic forces are represented by this equation, right? This question is where, see, this is for JEE examination, right? This is not in asking NEET. They are asked in JEE examination, right? Okay, you can just feel the importance of this topic, this chapter, units and dimensions. It doesn't mean we need to avoid it, right? See, first of all, for an hour we moved on, we build on to the foundation. Now slowly and slowly we are going on to the most important stuff, right? Slowly and slowly we are going to move on with the principle of homogeneity, then again, right, conversions, right, and relations and errors and micrometer screw gauge and Vernier Calliper, right? Anna? Okay, so this is really important. This is not what, right, what when say, okay, the unusual thing I'm talking in front, right? Okay, let's give you all a minute to solve this stuff. Come on. F is equal to alpha beta. Question solving approach, point number 3. E to the power dimensionless. E to the power terms dimensionless. It means that after evaluating this stuff, after evaluating this e to the power, this is dimensionless. This is one of the noteworthy points, right? Okay, this is dimensionless. It means that after evaluating x square by alpha k of t, this is a dimensionless, right? Okay, so it means that somewhere x square is equal to alpha k of t, and it means alpha that is equivalent to x square by kt. Dimensionally we are writing, as I said in question solving approach, nothing, right? We are saying this right from the, okay, mathematics point of view. So now x is a distance, t is temperature. So can I write alpha that is equal to distance L square, temperature K1. Now you got stuck with the Boltzmann constant. Boltzmann constant is not physical quantity that you are completely aware of, right? So it's important to write down the dimensional formula of, there is one equation 3 kt by m. v square into m, that is equal to 3k of T, mv square, right, whole divided by temperature, that is equal to 3k. So dimensionally k, that is equal to mv square by T, right? So dimensional formula of k, Boltzmann constant, is m1 L2 T minus 2k minus 1. We can derive, see, if you remember, then it's okay. Else, if you want to derive the dimensional formula of the Boltzmann constant, we are having this equation, right? We are having this equation. So it's m1 L2 T minus 2k minus 1, right? So we are going to replace, that is m1, right? This is only the Boltzmann constant is, na? Sorry, we are going to replace, right, into the denominator part, right? We are going to replace this stuff, that is m1 L2 T minus 1 k minus 1. This thing is going to cancel, L2 is going to cancel. So what alpha we are getting it as m minus 1 T1, right? M minus 1 T1. So successfully we have evaluated the value of alpha, but in question we are in need of a beta, right? In question we are in need of a beta, right? In question we are in the need of beta, right? So now what happened here? Okay, so in question we are in a need of beta, right? So here, suppose if I am rewriting this term, if e to the power this thing is dimensionless, it means this entire, okay, thing is having no dimension. So it means f is that is directly proportional to alpha beta, and beta will be f by alpha. Beta will be equivalent to f by alpha. So this is the first part of the solution, right? This is the second part of the solution, and right now we are dealing with the third part of the solution. First part, second part, and third part, right? So what will be the dimensions of beta? Dimensions of force, that is m1 L1 T minus 2. What is the dimensions of alpha we got? Right, m minus 1 and T of 1, right? So dimensions of beta, that will be equivalent to m of 2 L of 1 T of minus 3, right? M of 2 L of 1 T of minus 3, right? Okay, I think, sorry, here it is T minus 2, I'm sorry, right? This is T, okay, so this is going to be T2, right? So here it will be, okay, T2, and here we are going to have T4, I'm sorry, right? The small correction, okay. Okay, so it will be, I'm extremely sorry for that. Okay, this thing happens with students also, right? So it will be m of 2 L of 1 T of minus 4. This will be the dimensions of beta, right? Again, I'm rewriting it correctly. Okay. Okay, again, I'm rewriting it correctly. M1, right? L2 T minus 4. Okay, so B is the perfect answer for this specific question. Okay. Okay, question solving approach. Now let's move on to the next question of the principle of homogeneity. Okay, the velocity of the particle is given by v is equal to a of t plus b by t plus c of dash. A, B, C are the constant. The dimensions of A, B and C are. Okay, using this, right, equation, we need to calculate the dimensions of A, B and C, right? Okay, first of all, let's give you all a minute to solve this stuff, right? It's easy, right? And even you can, okay, solve, even you can pause the video. It's not a big deal. You can do anything you want, but I want you all to solve with me. That will increase the speed, accuracy and command over the subject, right? So you can do. the velocity of the particle. See, again, first of all, right? Let's move on to the question solving approach, the most important point, right? In the question solving approach, two physical quantities can only be added or subtracted. See, if it has been asked into the question, right, it means that, right, this equation is dimensionally valid. Why this T and C are added? It's not C dash, it's C, right? It's not C dash, it's C. Why T and C are added? If they are added, so, right, it means they are having the same dimensions. So it means dimensions of T, that is equivalent to, right, dimensions of C. So C is having the dimensions of T to the power 1, right? This is the equation number 1. Now, you can see, according to the principle of homogeneity, the dimensions on the left side, that is equivalent to the dimensions on the right side. But right side, we are having the two equations. So as I said, this will be the RHS of 1, right? And this will be the RHS of 2. So dimensionally, we can write LHS, that is equal to RHS of 1. Similarly, LHS, that is equivalent to RHS of another. Now, why I didn't write the C here? Why? Right? Why C is absent here? Because we are dealing that with the dimensions of the physical quantities. So whether I'm writing T or whether I'm writing C, right, the resultant of the T and C both will be same. Right now, you can understand that because they are added. Suppose, let us take an example. If the resultant of T and C, it is P. P is equal to T plus C. So dimensionally, we can say that P is equal to T, P is equal to C. So dimensionally, I have written this equation. So V is equal to AT. A will be velocity by time. That will be acceleration, right? So dimensions of A will be L1 T minus 2. B is equal to velocity into time. B will be displacement or distance, and that will be L1. Right? So B will be L1, right? C will be T1 and L T minus 2. This will be the perfect answer. This is the dimensions of A, this is the dimensions of B, and these are the dimensions of C, right? You can see how, right, using the noteworthy points from the question solving approach. The question solving approach, this thing I have kept in front, right? Because it is a part of the theory. Previously, it was a KVPY series, right? And we were dealing with the questions only, right? And we were doing the reverse engineering. From that, we are seeing into the theoretical part. But this is an actual what you all are in need for, right? Theory is coming in front. One question solving approach is coming, right? And that question solving approach, it is really helpful. Why? Because from those noteworthy points, already the question has been asked in PYQs. So you can feel the importance of that, right? Now, let's move on to the next part. Okay. First most application of the dimensional analysis we saw, unit conversions. It was principle of homogeneity, right? The first was principle of homogeneity. Now let's move on to the most important thing, units conversion. The second most important application, and from this also PYQ has been asked in JEE and NEET examinations. Now, what it states. First of all, I want to tell you all that any physical quantity, right, it is the product of two things. Any physical quantity that is a product of two things. One, that is N, second is U. N is always numeric value. Unit. Always physical, any physical quantity is defined by these two terms. As I said in my previous example, right? Mom slept. With what intensity? How it is measured? In what unit is measured? In what quantity it is, right, present? Okay. So physical quantity always comprises of these two things, and Nu is always constant, right? In two phases, N1, U1, that is always equivalent to N2, U2. How? In another sense, I can also tell N is inversely proportional to U. How? This will be the most important formula into the units conversion, right? This will be the most important formula, right, into the units conversion. See, suppose I am writing 1 kg, that is equivalent to 1000 gram. right? 1 kg, that is equivalent to 1000 gram. So can I say 1 is N1, kg is U1, the first unit, and that is equivalent to, this is N2 and this is U2. The amount, right, of a matter, 1 kg, is same as equivalent to 1000 gram. That's why I've written this, and this is also constant. N is inversely proportional to U. N is inversely proportional to U. So it means that, see, unit is higher, value is low. Unit is low, value is higher. That's why I've written this relation, N is inversely proportional to U. The higher the numerical unit, right, okay, the lower will be the unit system. Okay, na, lower will be the unit of the unit system. Higher, lower is the value, higher is the unit of the unit system. Lower, higher is the, first of all, again I'm repeating, sorry for this slip of a tongue. Lower is the value, higher is the unit of the unit system. Higher is the value, lower is the unit of the unit system, and is inversely proportional to U. This equation is satisfying this term. Right? If I'm writing 1 Newton, that is equal to something dyne, right? So you can understand this stuff, right? So any physical quantity that is comprises of these two things, N1, U1, it means that I can represent one unit system, right, in another. Now, unit conversions. Suppose I has been asked, I need to convert the 1 kg into some imaginary unit system, right? It is not compulsory. According to the dimensional analysis, you can create your own unit system, right? It's not a big deal. You can create your own imaginary unit system. Suppose here it is 1 kg. I am creating one imaginary unit system where 1 kg is thrice, right? So I can suppose that imaginary system is PW. So I can write now 1 kg, that is equal to thrice of PW. PW is a new unit of an imaginary unit system, where 1 kg is equivalent to 3 PW. PhysicsWallah. PW is an imaginary unit system, na? I can understand it doesn't exist. PW, this in units, right? Okay, this organization exists, right? But this is an imaginary unit system, 1 kg, that is equivalent to 3 PW. Higher, lower is the value, higher is the unit of the unit system. Higher is the value, lower is the, in another sense, N is inversely proportional to 1 by. What will be the question solving approach for this, right? We are going to use this stuff, N1 U1, that is equivalent to N2 U2, and that is also equivalent to constant, right? And first, N is inversely proportional to U, and third, graph of it, right? Okay, graph of it. Let's move on to the most important sum related to this. Select the correct graph. Select the correct graph. So first of all, yeah, right, see, you have to just use the question solving approach, okay, and solve this stuff. Come on everyone, 1 minute is there in front of you. Just use the question solving approach and solve this sum. Come on, less than 50 seconds are remaining. Come on, guys. Select the correct graph among the all. Simple. N is inversely proportional to U. It means that N is the higher side, U will be the lower side, U at the higher side, L will be at the lower side. So it means they are having the hyperbolic kind of graph. This thing you all are aware of, right? But I'm going to tell the most interesting fact about it. If I need to plot the N versus U graph, right? It is a kind of a curve first. But what about N versus 1 by U graph or U versus 1 by N graph? This is the straight line. Right? How? Suppose if I'm using this N is inversely proportional to 1 by U. N is inversely proportional to 1 by U. Right? Then how we are going to resolve this? Right? Removing this proportionality sign, can I say N is equal to K by U? It is following Y is equal to mx with 0 intercept. Right? It is following the equation of the line Y is equal to mx, right, with the 0 intercept. Right? What is the equation of the line? Equation of line is Y is equal to mx plus C, na? Right? If intercept is 0, then equation is Y is equal to mx. So N is equal to K by U, right? For this second graph, right, B is also correct. Right? B is also correct. So it means that A and B, right, these two are the perfect answer for this specific question. Right? A and B, these two are the perfect answer for this specific question. Right? Now let's move on to the next part. How we can represent, right? Okay, this is a very simple example. 1 Pascal into the CGS unit system. Unit conversion. We need to represent 1 Pascal, right, in 1. How much? So can I say it's very simple. Now this is N1, right? This is U1, this is N2, and this is U2. We need to calculate the value of N2. Right? We need to calculate the value of N2. Right? In another sense, you can move on to the we can have a very simple approach also. Right? Okay. Pascal, pressure is equal to force per unit area. 1 Newton per meter square, that is equal to dash CGS. Right? Okay, can I convert this Newton per meter square? Right? So can I write it as kg meter square per second square into meter square? Right? Now, pressure, that is, see, Pascal is a unit of pressure. Pascal is the unit of pressure. Pascal is Newton per meter square. That's force per unit area. These are the dimensions of force. This is the dimensions of area. Right? Okay. Newton, can I replace it? I'm extremely sorry. Newton is kg meter per second square. Right? Newton is kg meter per second square. So can I replace, see, 1 Newton per meter square, that is equivalent to dash, right, kg meter, this thing is going to cancel, that is kg by meter second square. Can I replace, right, kg as 10 to the power 3 gram, meter as 10 to the power 2 centimeter, right, and second square will be same. Right, second square will be same. Okay, kg per meter second square. This is what the dimensional formula of the pressure is, na? See, pressure, that is equal to force per unit area. Force, that is equal to m1 L1 T minus 2 whole divided by L2. Right, so this will be m1 L minus 1 T minus 2. This is the dimensional formula of pressure. This is the dimensional formula of stress. Right, we have seen in the previous part of this session. See, yes, m1 L minus 1 T minus 2, right? m1 L minus 1 T minus 2. Okay, see now. Okay, now lots of stuff we have seen here. So m1 L minus 1 T minus 2. So kg into gram. This is the CGS unit system, the gram per centimeter square. So it's 10 to the power 2 meter to centimeter, right? So it will be 10 to the power 1. So 1 Newton per meter square is 10 of CGS. Right? 10 to the power 1 of CGS. Right? This is how one unit are converted into another. Right? Okay. Now, one sample question I am going to give in front of all. Another, how we can use N1 U1 and N2 U2. the best application for this expression, best application. Suppose I want to convert 10 Newton in imaginary system PW. Imaginary unit of imaginary unit system. 10 Newton, I have to convert this into this. Where mass is double, length is half, time is twice. What are the new characteristics of the PW? Mass is double, length is half, time is twice. So in this case, how we are going to deal with the stuff? Right, see, we are going to use the same formula. This is N1 U1, N2 U2, right? N1, it is 10. U1, can I write the dimensional formula of Newton? M1 L1 T minus 2. Now we need to calculate N2. Now in this new unit system, okay, I need a space. I need a space to solve this stuff, right? See, N1, that is 10. Okay, Newton, I'm writing it as a dimensional formula M1 L1 T minus 2. What will be the N2? N2 I need to calculate. What will be the U2? This is the second approach. In previous, we directly, right, we are aware of the conversion, right? So we directly applied it and we got the answer. But suppose if I'm having one new physical imaginary unit, right, of an imaginary unit system in front, and how we can use this equation, we are going to deal this stuff. N2 U2, N1 U1, that is equivalent to N2, N2 U2. New U2, mass is double, 2m power 1. Length is half, L to the power 2t minus 2. M1 L2 T minus 2. So this will be 10 M1 L1 T minus 2. This is N2 M1 L1 T minus 2 into 2 to the power 1, 1 by 2 to the power 1, 2 to the power minus 2. Right? So this thing we are going to cancel it. So 10 is equal to N2. 2 is also get by 4. N2 will be that equivalent to 40. So how we can write this stuff? 10 Newton, that is equal to 40 PW. PW is a unit, right? Imaginary, the unit of an imaginary unit system. So this is a new way, new approach by using, this is the best application of N1 U1 and N2 U2. The best application, right? If you want to take this snap, you can have it, right? If you want to take this snap, you can have it. Okay. Now, let's move on to the next part. So this was the second. Now, third, dimensional analysis, the three most noteworthy things into the dimension. One, that is the principle of homogeneity. Second, those are unit conversion. The third is deriving relation between the physical quantities, right? Deriving relation between the physical quantities. Friends, what is the relation between them? How we can derive this relation, right? How we can derive our relation with our own friends, how we can derive a relation with our own relatives, right? I'm going to show you. Indrajeet is directly proportional to friends, right? And family. Indrajeet is directly proportional to friends and family. Right? Sorry, family is not included. I'm extremely sorry. Okay, I'm going to remove that stuff. Okay, Indrajeet is directly proportional to friends. How friends are useful, Indrajeet is useful. How friends are not useful, Indrajeet is useful. Right? Because Indrajeet is Indrajeet. But Indrajeet is inversely proportional to enemies. Enemies are at the highest position, Indrajeet never cares. Enemies are at the lowest position, Indrajeet cares. Why? There is no opposition. Right? Even the Honorable Prime Minister of the country is also having the oppositions, right? Again, so opposition is a part of a life. Okay, you should be proud that someone is opposing. So that's why I've written this relation. If enemy are at peak, right? Indrajeet never cares. It is at the lowest position, never cares. Right? But if enemies are at the lowest position, whoa, I have done nothing. And no one is opposing me. You can understand, na? Denominator is higher, this one is lower. This one is lower, higher, this one is lower. Enemies at the peak position, Indrajeet never cares, lowermost. No, never cares. But enemies, right? Those who are opposing, they are at the lowermost position. Indrajeet cares. Indrajeet at the peak position. I haven't done anything, because those who are doing something, they are always opposed, right? So this is the best example, right? Okay. It was just a fun part, Hana. I'm only the person, right? Okay, that is having no enemy. It's okay, yeah. No one is having the enemy in their life. It's just a psychological difference and the priorities. Mark my words. It's just a psychological difference in priorities. Okay. So this deriving relation between the physical quantities. Deriving relation between the physical quantities. Suppose let us take an example. Length depends on mass, right? Force, density. How? See, suppose if I want to represent any derived physical quantity in terms of fundamental physical quantity, I am having the dimensional formula. But suppose if I want to represent any physical quantity in terms of derived, then I can use this concept. Again, I am repeating, if I want to derive the equations, or if I want to, what we can say, represent any physical quantity in terms of fundamental physical quantity and their dimensions, I am having the concept of dimensional formulas. But, if I want to represent something in terms of dimensions of derived physical quantity, then I am having this stuff. There is only single question solving approach, nothing is there. Powers of physical quantities on left side, that will be equivalent to powers of physical quantities on right side. Powers of physical quantities on the left side. In another sense, what is the question solving approach? Yes, LHS, that is equivalent to RHS. We can compare the powers on the both sides, the dimensions of the both sides we can compare. It's the same thing we did into the principle of homogeneity, but we are seeing this stuff into the bit different way. The first question appears in front of you all. If speed V, area A and force F are chosen as the fundamental, see, Young's modulus is Y. It depends on speed, force and area. I'm sorry, speed, area and force. Okay, eraser. Speed, area and force. Area and force. I want to represent the Y. See, I can represent the Y in terms of MLT, but I want to represent Y in terms of derived VAF. How? We can use this concept. Same question solving approach, the powers on the LHS, that is equivalent to powers on the RHS. But before moving on to that, I'm giving you all a minute to solve this stuff. So there is 1 minute. Come on guys, you can solve this stuff. Speed V, area A, just powers on the LHS to the powers on RHS, right? Powers on the LHS and equivalent to powers on RHS, right? Okay, very simple thing, right? We are going to solve this stuff within short period of time and you are going to enjoy, right? Okay, hope so this lectures and this series will be helpful for you all, right? speed v area. Okay, see. Again, I'm writing this stuff. Y is directly proportional to V to the power A, area to the power B, force to the power C. Y is the Young's modulus, and Young's modulus is having the same dimensions as that of the stress and pressure. Right? Young's modulus is having the same dimensions as compared to the stress and pressure. Right? Now, LHS. Can I write the dimensional formula of LHS? That is M1 L minus 1 T minus 2. This is the dimensional formula of Young's modulus. M1 L minus 1 T minus 2, dimensional formula of Young's modulus. On the right side, what is the dimensional formula of velocity? L1 T minus 1 whole to the power A. What is the dimensional formula of area? L to the power 2. What is the dimensional formula of force? Right? That is M1 L1 T minus 2 whole to the power C. Right? A simple stuff. I have replaced. See, Y is a Young's modulus. See, how we derived Young's modulus? It's very simple. Young's modulus, that is equal to stress by strain. Right? Strain is dimensional as stress is force per unit area. Right? Okay, dimensionally I'm talking about. So that is M1 L1 T minus 2 whole divided by L2. This thing is going to cancel. Y is equal to M1 L minus 1 T minus 2. Now, on the LHS side, right, we are having what? It is M1 L minus 1 T minus 2 is directly proportional to L to the power A, T to the power minus A, L to the power 2B, M to the power C, L to the power C, T to the power minus 2C. We are going to multiply this stuff, right? And this thing came up in front. Now, see, I'm going to add L and L. I'm going to add T and T. This L is also added, and I'm going to rewrite this term. M1 L minus 2 T minus 2 is directly proportional. First of all, I'm going to write M to the power C. Right? Then I'm going to write it as L. A, 2B and C. It's A plus 2B plus C. Now I'm going to write as T minus A minus 2C. Simple. LHS, RHS. Powers on the LHS we need to compare with the powers on the RHS, right? Powers on LHS. See, if I am seeing the powers of M, they are equal. We got the value of C. If we can compare the powers of C, right, then we are having minus A minus 2C, right? That is equivalent to minus 2. If we are replacing C as 1, minus A minus 2, that is minus 2A will be 0. Right? A will be 0. C will be 1. Right? Okay. Again, minus 2. If we are comparing this dimensions of T, minus A minus C is 1. Right? Okay. Now, if we are going to compare the dimensions of L, then what we are going to have? Right? This is the first part. Right? And this is the second part of the solution. Okay. L. Minus 1, that is equivalent to A plus 2B plus C. Right? What is the value of A? 0. 2B plus 1 minus 1. So B will be minus 2 by 2. B will be minus 1. So we are having A is equal to 0. B is equal to minus 1. C is equal to 1. So if I want to represent this thing, so can I write it as Y is directly proportional to V raised to 0. A is 0 na, right? B is minus 1. F is 1. This is the perfect answer. So if I want to represent this stuff, then Y is force per unit area that we got. Okay, this one. D is the perfect answer for this specific question. Right? D is the perfect answer for this specific question. The same thing, right, we did. Okay, see. Powers of LHS, just evaluate an LHS, right, is equivalent to RHS. This is a question solving approach. Force, acceleration and time are chosen as the funda. Suppose, as I said, physics depends on why and suppose. Suppose force, acceleration and time are chosen as a fundamental physical quantity. Defines energy. Energy right, is directly proportional to force to the power A, acceleration to the power B, right, time to the power C. Force, acceleration and time, right. NEET 2021, it has been asked. Previous question was in, right, 2020, okay. So let's identify the correct relation. Come on, everyone. Okay, I'm giving you all a minute to solve this stuff. So this was the last part of the dimensional analysis. After this, we are going to deal with the errors and we are going to deal with the Vernier calipers and micrometer screw gauge. Okay, same thing, the same question solving approach we are going to use in this. Energy. What is the dimensional formula of energy? We are having it is m1 l1 t minus, I'm sorry, m2 l2 t minus 2. Force, it is m1 l1 t minus 2 to the power A. Acceleration, l1 t minus 2 whole to the power B. Time, t to the power C. Right? So if I'm rewriting this thing, so can I say this is m1 l2 t minus 2 is directly proportional to m to the power A, l to the power A, t to the power minus A, l to the power B, t to the power minus 2b, t to the power C. Right? Rewriting this equation by joining the relevant dimensions, m1 l2 t minus 2, it is directly proportional to m to the power A. Okay, combining L. So we are having L is equal to L to the power A plus B, t to the power minus 2A minus 2B plus C. Comparing LHS and RHS, comparing the powers of M, we are getting A is equal to 1. Comparing the powers of L, we are getting A plus B, right? How much? A plus B, that is equivalent to 2. Okay, A is equal to 1, B is equal to 1. Replacing A is equal to 1, we get B is equal to 1. See, now third equation, minus 2A minus 2B plus C, minus 2A minus 2B plus C, that is equivalent to minus 2. AB is 1, so minus 2 plus C is minus 2. C is equal to minus 2. Right? So how I can represent the energy? Energy that is directly proportional to A1, B1 and F to the power 1, acceleration to the power 1, e to the power minus 2. Right? Okay, so that's an energy and that's the perfect answer. It has been asked in NEET 2021, F1 A1 t to the power minus 2. Right? F1 A1 t to the power minus 2. Okay, this is a perfect answer. Okay, I need to rewrite this. Okay, it's not about what it is C, A, B or D. This is a perfect answer, right? And I've rewritten. Okay, there is a bit of error, but it's okay. This is a perfect error. Okay, this is a perfect answer for this specific question. Okay, now let's move on to the next part. Momentum, area and time are taken to be the fundamental quantities and dimensional formula of energy. Energy is directly proportional to momentum, area and time. Without wasting our time, we are going to solve this stuff. Energy, that is m1 l2 t minus 2. Now you can write it directly also. You are aware of now what is the dimensional formula of momentum, that is m to the power A, l to the power m1 l1 t minus 1. Okay, t to the power minus A. Area, l to the power 2b, t to the power c. Right? When you will try to solve this kind of stuff, now you will have the practice for that. Right, so it is m1 L2 t to the power minus 2 directly proportional to m to the power a L to the power a plus 2b and t to the power minus a plus c. Comparing the dimensions of m, a will be equivalent to 1. Comparing the dimensions of L, a plus 2b is equal to 2, a will be 0. Right, okay, and comparing the dimensions of, right, minus t, that is minus a plus c, that will be equivalent to minus 2. A will be 1, right? So C will be minus 2 plus 1, C will be minus 1, right? So how I can represent this energy? Energy, right? It is directly proportional to, energy is directly proportional to momentum, right? Momentum is P, okay, to the power A. Okay, we have done a mistake. Okay, we have done a mistake. We're going to solve this stuff again. So this kind of the mistake you can do, it's okay, it's not a big deal, but we are going to solve this stuff. A is equal to 1. Now we are comparing A plus 2B, right? That is equivalent to 2, right? So if A is equal to 1, if I'm comparing the dimensions of L, then A plus 2B, that is equivalent to 2. If A is equivalent to 1, then 2B, that is equivalent to 1B, will be equivalent to half, right? B will be equivalent to half, yes. Right, now minus A plus C, comparing the dimensions of this will be minus 2. So A will be 1, minus 1 plus C, that will be equivalent to minus 2, C will be minus 1, right? So momentum to the power 1, right, area to the power minus half, T to the power minus 1, right? Sorry, this will be half, okay, because value of the B is half, right? So this will be the perfect answer. I'm rewriting this term, right? Okay, A to the power half and T to the power minus 1. Okay, A to the power half, T to the power minus 1. Okay, this is the perfect answer for this specific question. Okay, so this is how, this is the third application of the dimensional analysis, right? This is one for you all. This is a homework question. You can write this stuff. Okay, this is the homework question. You can write down. Okay, you can write this. You can just solve this and answer this beneath the video. You can answer this stuff beneath the video. Now, errors. Errors. We are going to see this stuff, the most important stuff, into the very convenient, into the very funny way, right? So, are you all ready? Are you all ready, guys? Errors. Errors and errors. See, if I'm talking about our day-to-day life, right? Errors is a mistake, right? But what is the significance of error from a physics point of view, right? Say it means, let us take a very simple example. If I'm conducting an experiment, right? Let us take a very simple example. If I'm conducting an experiment, right? In that experiment, I am measuring one physical quantity that is defined as A. If I'm conducting one experiment, in that experiment, right? If I am measuring, right, one physical quantity A. In that experiment, right, 1 will be the true value of A. And second will be the measured value. 1 will be the true value of A and second will be the measured value. Right. What is an error? Let us take an example. If I have conducted an experiment to measure the G, the gravitational acceleration of the Earth, I got the value as 9.7 meter per second square, right? This was my measured value, MV. What is the true value of this G? It is 9.8 meter per second square, right? It means, okay, I have conducted one kind of an error. There is an error in my experiment, right? What is an error? Simple. If I want to define difference between right? Okay, difference between true value and measured value. The difference between true value and measured value, that is error. The simple explanation, right? Now, errors, right? Further, if we are talking about the errors, then there are some relevant spatial cases for that, right? What are those? I think it's lagging. Just hold on, right? It's lagging as because of the high visualizations, right? As because of high visualizations, right? It lags. Okay, come on, man. Basically, this is an example of an absolute error. Three kind of errors are there. The first one, that is an absolute, second that is a relative, and third one, it is a percentage, right? Now, what is an absolute error? Okay, when daughters, right? Okay. Kindly consider this as a right fun, please. Okay, this message is not right having any kind of a discrimination between the boys and girls. A strict disclaimer in front. Okay, when a girl, when a daughter does a mistake, papa, okay beta, it happens. And when a boy, that's an absolute error, right? What truly should be done? There should be the equal punishment for the daughter and son, right? Truly speaking, there should be an equal punishment for a daughter and son, but something error is going on. Absolute difference between true value and measured value is an absolute value, is an absolute error. The difference between the true value and the measured value, that is an absolute error, right? When daughter does a mistake, appa. When the son makes a mistake, there is appa. When daughter does a mistake, appa. When son does a mistake, appa. Right? Okay. So this one, absolute error. Like, let us take an example. Let us take another example as a pocket money, right? Or I got a 10 rupees from my father. But after some days, suddenly my system is showing I gave you 11 rupees. What was the actual amount I received? 10. What is the amount that system has measured? System is showing 11. What is the difference? True value 10. Measured value in the system 11. Difference error. It's an absolute error. Now, absolute error can be positive. Absolute error can be negative. Absolute error can be 0. Absolute error can be positive, absolute error can be negative, absolute error can be 0. But, keep one thing in mind. Let us take another example to understand this. Papa gave me 10 rupees as a pocket money. In system, it was showing 11. What is the difference? 1. Papa gave me 10 rupees in system, it was showing 9. In this case also, there is a difference of 1. But in one case, right? Okay, there is a negative error. In one case, it is a positive error. In magnitude terms, error is of 1. So absolute error is positive, negative and 0, right? Okay, I can define it as a delta A is an absolute error, that is true value, right, minus measured value. True value minus measured value, right? True value minus measured value, right? It can be positive, it can be negative, but when percentage error is calculated, absolute error is always taken as positive, right? Suppose my papa gave me 10 rupees, system was showing 11, there is an absolute error of 1. Relative and percentage, if I'm talking, then we are talking about the fractional part. So in that case, the errors are always positive. We have to take the absolute errors as positive values. Magnitude we need to consider. Now, the second type of the error is relative. fraction of absolute error to the true value. That is the relative error. Fraction of absolute error to the true value. My reaction when dad asked me, where are all the pocket money I went? My reaction when dad asked me, my dad gave me the ample amount of pocket money. Among that, he is asking right now, how much did you spend and how much did you save? Fractional. Amount, see, of X amount of a pocket money, how much fractional part did you spend? So that's the same thing. Again, I'm repeating the same example. If my dad gave me the pocket money of 10, his system is showing 11. What is an absolute error? 1. That absolute error is what fractional part of true value? That 1. Dad gave me 10, system was showing 11. Absolute error is of 1. That 1 is what fractional part of the true value, that is 10, and that is 1 by 10. That is a relative error. So relative error, we can define it as delta A by A. When it is multiplied with respect to the percentage, we are getting the percentage error, right? Okay, percentage of, right, relative. Okay, so it means when we are multiplying the relative error with 100, okay, so that is the percentage error. Right, whenever we are multiplying the relative error, right, with this, then it is a percentage error. Okay, so we are defining it as 100 into relative. We are defining it as 100 into relative, right? So these are the 3 types of the error. Apart from this, lots of things are there, right? But in this case, right, basically 2 kind of questions are always asked. The first one, if we are, see, in all of those cases of the errors, we are conducting an experiment. In all of these cases of the errors, right, we are conducting an experiment. In experiment 1, only one physical quantity is measured. Only one physical quantity, right, is measured, right, and combination of physical quantities are measured. I am conducting an experiment. Basically, there are two ways, right? This classification is according to the question point of view. How questions are asked into the examination, right? It is according to the question point of view. I am conducting in one experiment in which, right, only one physical quantity is measured, right? Okay, and in another, the combination of the right physical quantities are measured. The most important point, right? If there are n number of observations, it means that we are having n number of absolute values. Absolute errors. If this is the most important note, if we are conducting an experiment in which one we are physical quantities we are measuring, right? In school also, in labs also, you have seen, right, whenever you are conducting an experiment, you used to take, right, more than one reading, like 2, 3, 5 something, and finally you are averaging out all of those stuff, right? The same thing, if we are having the n number of the observations in an experiment, it means n absolute errors are there. For n observations, we need to have a true value by taking average. For actual absolute error, we need to take out the average. See, this thing is we are going to see into the sum. Okay, so first of all, the first question appears in front of you all, right? Okay, in an experiment, while measuring the physical quantity, observations noted as 1.34561. The percentage error, see, I was measuring, I have conducted one experiment, I was measuring all of those values, right, and got the 5 observations, 1.3. I'm not aware of what is the true value. I'm not aware of what actual the true value is. I'm not aware of what actual the absolute error is, but I need to calculate the percentage error in this stuff. So first of all, let's give you all, there is a small procedure. Let's give you all a minute to solve this stuff, right? And we are going to discuss the solution here only. There is a very common procedure to solve this kind of the sums, right? I am conducting an experiment in which the individually one, right, physical quantity is measured and the observations are demonstrated like this way. The observations are demonstrated like this way. Come on, everyone, right? Fast. Less than 10 seconds remaining. Come on, everyone, those who are live. In an experiment, see, it's a very simple stuff. How many number of the observations are there? Right, 1.3, 2, 3, 5 observations are there. Right, we are having the 5 number of the observations. It means that first of all, we are not aware of the true value. So in this case, what we have to do, your first step will be to calculate the average value, and that average value will be our corrected one. So first of all, what will be the average value? The average value, it will be equivalent to 1.3 plus 1.4 plus 1.5 plus 1.6 plus 1.7 whole divided by 5. So the average value that will be equivalent to, right, 1.5. Can I consider this as equation number 1? Yes, we can consider this as equation number 1. Now, second, this was the first part. Now second part. What is, see, as I said, n number of the observations, n number of the absolute errors. So what will be our first absolute error? What is our true value? 1.5, right, minus 1.3. It will be positive 0.2. Second absolute error, 1.5 minus 1.4, it is positive of, right, 0.1. Third, 1.5 minus 1.5, 0. A of 4, the fourth absolute error for the fourth observation, 1.5, 1.6, negative 0.1, right? Fifth observation, 1.5, right, minus 1.7, that is negative of 0.2. Absolute error can be positive, can be negative, can be 0. Same thing, positive, 0 and negative. But what is our actual absolute error? Again, we need to take the average out for this. But whenever we are taking the average out, we need to calculate the magnitude, right? Because we are going to calculate the percentage. So average absolute error, right? So that will be equivalent to what? 0.2, 0.2, 0.1, 0.1 whole divided by 5. Right? Okay, whole divided by 5. So it's 0.2 plus 0.2, 0.4, right? Okay, this is an average absolute error. So we are 0.2, 0.4, 0.6. Okay, it's 0.012, right? So this will be the average absolute error in an experiment, right? Can I consider this as equation number 2, right? But we need to calculate the percentage error. So how we are going to calculate the percentage error? This will be the third part, right? The percentage error will be the mean absolute by mean value. Mean absolute is 0.012 by mean error, mean is 1.5. So we are getting it as 0.08, right? Percentage, 8% will be the perfect answer for this specific question. This is how this kind of sums are solved, right? This is how this kind of sums are solved. Now, let's move on to the next question. See, this question has been asked, right, September 6, 2020, right? A student measuring the diameter of the press cell cross section using the Vernier scales, right, and following 4 readings, 5.5, 5.55, 5.45, 5.65. The average of this 4 data is 0.73. The average diameter of the pencil should be therefore recorded as, right? So this thing, right, you can answer, right? Okay, and this is the homework question. The same thing, the same procedure, right? This is the homework. Okay, now combination of the errors. See, there is a proof of the combination of the errors, right? But generally, right, we are using it from the question solving approach only, right? Okay, we are not doing, we are not into that much part. Okay, we are not going into the details of the derivation, right? Either you can move on, you can move on, but these combinations of errors are having some cases. Like first, if see, Z is a physical quantity that is a combination of the two, A and B. I'm measuring an experiment, right, in which the result is Z, but it comprises of two physical quantities, A and B. Either they can be added or they can be subtracted. So there is a derivation, you can apply the log and everything, lots of stuffs are there. But we are not interested in derivation, right? If you need to calculate this absolute error and the relative error for this. So absolute error, in the case of addition and subtraction, we are directly moving on to that part. That is delta Z is equal to delta A plus delta B. Delta Z is equal to delta A plus delta B. If you need to calculate the relative error, right, in the case of addition and subtraction, right, so relative error, that will be delta Z by Z. It will be delta A plus delta B whole divided by A plus B in case of addition. In case of subtraction, it is delta Z by Z. That is, absolute errors are always added because we are going to take the fractional part. So in case of subtraction, it's like this. So this is the first case in the combination of errors, right? Okay, this is the first case in the combination of errors, right? That is when two physical quantities are added or subtracted, right? How we are going to resolve this stuff, right? When two physical quantities are added or subtracted. When two physical quantities are added or subtracted. Now, second case, if we are talking about when two physical quantities are multiplied or divided, right? When two physical quantities are multiplied or divided. So in that case, it's a very simple thing. Suppose, right, two physical quantities are multiplied, then we are having the, see, if it is a case of addition and subtraction, then easily we can calculate the relative error, absolute error. If it is a case of multiplication and division, right, we can calculate the relative error. Same, the derivation of this, we can apply this log and all of those stuff and we can use this, right? But we are not moving on to that part. We can directly, right, remember this formula. It's not a big deal. So Z, delta Z by Z, that will be equivalent to delta A by A plus delta B by B, right? Delta Z by Z is equal to delta A by A plus delta B by B. What will be the, see, this is a relative error. You can multiply by 100 and get the percentage error, but what will be the delta A by A plus delta B by B, right, into Z. This will be the absolute error. If it is a case of multiplication, right, if it is a case of multiplication, then delta Z is equal to delta A by A plus delta B by B, right, A into B. If it is a case of multiplication. If it is a case of division, then delta Z is equal to delta A by A, right, plus delta B by B, right, and that is A by B. The third case is of, if I'm measuring, right, I'm conducting an experiment in which one physical quantity n times is measured. So for that relative error, I can write it as delta Z by Z is equal to n delta, right, A by A, right, and this n delta A by A, this is an absolute error into Z, right? So this is all about the combination of errors. If you want to take a snap, it's not a big deal, because using all this, see, this is only the question solving approach, right? Okay, depending on the, but one new thing we are going to discuss in this, right, related to the error, a really awesome thing we are going to discuss, right, and you have to just wait and watch. Okay, really awesome thing we are going to discuss, you have to just wait and watch. Okay, this is a basics question solving approach. When it is in case of addition and subtraction, we have to apply this stuff. When it is a case of multiplication and division, we have to apply this stuff. And when it is a case of this kind of things, it's simple, case to case basis, everything is going on like case to case basis. Okay, just identify the case and apply the formula. So this is a kind of the combination of errors and even the question solving approach for this stuff, right? Okay, question solving approach. right? First question, 2018, it has been asked. It's a very simple thing, right? 2018. The percentage errors into the quantity P, Q, R, and S are 0.5, 1, 3, and 1.5. We need to calculate the percentage error in A. We need to calculate the percentage error in A. Okay, let's give you all a minute to solve this stuff. Come on, everyone. Right? Less than 20 seconds remaining. Come on, everyone, those who are live. Approximately, right, 2.5 hours and of lectures we have completed. And after this error, two most important topics related to this chapter, that is Vernier Calliper and screw gauge. This thing is remaining, and it will take approximately 45 to 1 hour of the time, and this session will be over, right? The percentage errors into the quantity. See, simple. It is okay. A, that is given as P of cube, Q of square under root of R into S. So can I write delta A by A, that is equal to 3 delta P by P plus 2 delta Q by Q plus half delta R by R plus delta S by S. Right? Can I multiply both sides by 100? Can I multiply both sides by 100? Right? Okay. Now, percentage error in P is 3 into 0.5 plus what is the percentage error into Q? 2 into 1 plus what is percentage error into R? Right? 3 by 2 plus what is percentage error into S? 1.5. Right? So finally we are getting it as 1.5 plus 2 plus 1.5 plus 1.5. Right? So it's 6.5 percentage. D is the perfect answer for this specific question. Like this way, right? Very simple questions related to the errors are asking to the examination. Right? Now, let's move on to the next part. Aha, awesome question came. Generally, right, it has been asked in series. This parallel. Generally, it is asked in series, right? Okay, but this is parallel, right? In parallel also, right, two formulas are used, right? Suppose here it is written while two resistors R1 and R2, right, they are connected in parallel, right? Calculate the equivalent resistance in the circuit. Calculate the equivalent resistance in the circuit. What is the formula of parallel? 1 by R, that is equal to 1 by R1 plus 1 by R2. How we are going to solve? R is equal to R1 R2 whole divided by R1 plus R2. One question was asked, right, in JEE examination, right? Okay, from this we can derive two formulas, right? Two formulas are for there, right? First of all, let's move on to the, okay, 1 minute. Let's give you all a minute to solve this stuff. Come on, everyone. First formula, right, we are going to use, see there is one direct formula, right, that is delta R by, right, R square, and that is equal to delta R1 by R1 square plus delta R2 by R2 square, right. This is for the parallel, right. This is for the parallel, delta R1 by R1 square plus delta R2 by R2 square, right, plus delta R by R square, right. Okay, it's okay. Okay, so now we are going to solve this stuff right now. So delta R by R square, there is one error here. We are having the value of 1.71, 1.71, right, 1.71 and 1.71, right. Okay, this thing, there is one small error. Okay, so delta R by R square, that is delta R1. What is delta R1? 0.03, right, whole divided by 16 plus 0.01 whole divided by 9. So here the absolute error will be, right, 0.03 whole divided by 16 plus 0.01 whole divided by 9 into R square. What will be the equivalent resistance of 4 and 3 when they are connected in parallel, right? So it will be equivalent to R equivalent, that is equal to 4 into 3 by 7. So can I write it as 16 into 9 whole divided by 49. So delta R we are going to get it as 0.08. Right, and this will be 1.71 approximately. C will be the perfect answer for this specific question, right. C will be the perfect answer for this specific question. Okay, C will be the perfect. So this is an actual formula. Okay, in another sense you can also solve this stuff, and that is okay, R is equal to R1 R2 whole divided by, right, that is R1 plus R2. If we are considering this as a physical quantity, that is delta R by R, that is delta R1 by R1 plus delta R2 by R2, right, plus delta R1 plus delta R2 whole divided by R1 plus R2, right. This is another formula, right. For parallel connection we are having the two formulas. Okay, a physical quantity is described by the relation P, that is equal to A to the half B square C cube D to the minus 4. If the relative errors into the measurement of A, B, C and D are 2, 1, okay, directly we can solve without wasting the time. Delta P by T, that is half delta A by A plus 2 delta B by B, right, plus 3 delta C by C, right. Errors are always positive, so that's why n value is always positive. Right, we have always, here we can write minus 4, right. So this will be, A is having the percentage error of 2, so this will be 1, B is having the percentage error of 1, so this will be 2 on multiplying both sides by 100, right. So this thing will be converted into percentage error. So B is having, see, okay, B is having the percentage error of 1, C is having the percentage error of 3, and D is having the percentage error of 5, right. So this will be 20 plus 9 plus 3, 32%, right. C will be the perfect answer for this specific question. 32% will be the perfect answer for this specific question, right. Okay, apart from this, this will be your homework, right. It is very easy, you can solve this stuff and you can directly answer this into the comment box. Okay, now the new thing that is going to come, what is in this chapter? See, you can just pick up the float. We started from physics, we moved on to the physical quantities, units, right. We moved on to the classification of the physical quantities, right. Okay, supplementary, fundamentals, derived and supplementary, right. We seen all of those stuff. Then we moved on to the homogeneity, dimensional formulas, homogeneity, right, and 3 applications of dimensional analysis. Slowly then we moved on to the errors. Right now we are moving forward to the calipers, right, calipers and micrometer screw gauge. So first of all, I want to ask you a question. You can say in front, why Vernier Calliper? Why? As I said before, physics completely depends on why and suppose. Why Vernier Calliper? Right? For this, I want to again take an example for the day-to-day life. Right? Okay, suppose there is an error. Right? Okay, it was a Sunday, and suddenly I wake up in the morning and I saw, right, my father was repairing something at the corner of the room, in the corner of the room, right, and suddenly, right, he just turned and say, Indrajeet, I need 2 meter of wire. You just immediately move on to the market and just buy this kind of wire, right, because there is a kind of a bit electrical fault in my house and I'm trying to repair it. There is a wire cut in the corner of the room and I'm trying to, right, repair it. So for that I need an approximately 2 meter of wire. So I immediately went on to the market, right, and went on to an electrician to meet an electrician, and I demanded for the 2 meter of wire. What he did, how he measured, 1, 2. In the Sunday evening, I was waiting, right, for a cup of tea. And suddenly I heard from my mother, right, there is a shortage. So immediately with a cup, I went on to my neighbor house and I asked, can I have the, what you can say, small amount of sugar, right? So she said yes. Okay, she said yes. So here, right, a new thing that we got, okay, when I was measuring the length, I measured it like this way. This was 1 meter and this was 2 meter. Was it accurate? No. When I demanded for sugar, I said just a small amount. Right. Was it accurate? Did I demand it for 500 gram of sugar? No. Did I demand it for 20 gram of sugar? No. What I demanded, small amount of sugar. So here the question lies, why there is a need of a caliper and the micrometer screw gauge. So the answer lies behind this meter scale. Suppose if I'm talking about a meter scale, right? Okay, let us take in a very simple example. Starting from 0, there is a 30 centimeter meter scale. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like this way it moves on, right? Like this way it moves on, right? Okay, 30 centimeter of scale. Suppose if I want to measure the value 1.5 centimeter, can I do that using the measure scale? Yes. Suppose if I want to measure 1.52, it's a matter to worry. Can I do using the measuring scale? Wrong. Suppose if I want to measure up to the 3 to 4 decimal places, right? 1.5345. Can I use, right? Can I measure this value using the measuring scale, measuring tapes, right? For small, right, measurements, we are using the scales. For long measurements, right, we are using the tapes, right? Okay, but what about a very accurate measurements up to 2 decimal places, up to 3 decimal places, up to 4 decimal places? At that point of time, the measuring sticks and the measuring tapes and the ruler, right, get fails. So generally, the Vernier Calliper and Micrometer Screw gauge are able to measure more than 2, 3, 4, 5 decimal places. But what happens? The number of the decimal places are increased, right? The digits, whatever coming out, we are less confident about that. The number of the significant figures, right, they get decreased. We are less confident about that, right? We are less confident about that. Okay, so why Vernier Calliper? Why Vernier Calliper? As usual, as a replacement of the, right, measuring stick to see, generally up to 2 decimal places. Generally up to 2 decimal places. General measurement up to 3 decimal places. Right, we are using this stuff. For 2 decimal places, we are using Vernier Calliper. Right. Okay, and second, right, we are using this as micrometer screw gauge. They can measure, right, more accurately also. It completely depends on the range of the instrument, whatever we are using. But this is the replacement of the meter sticks, right? That's why we are using. Why caliper, right? We got our answer. Why we are studying this? We got a caliper. Why, right? Okay, why? Okay, why? Now let's move on to what kind of an apparatus it is, right? Okay, what is the question solving approach for this kind of this stuff? What is the zero error? What is the least count? All of this stuff we are going to see. See, Vernier Calliper, right? This kind of the instrument it is there, right? Basically it is having two scale. One, it is a main scale, right? Second, it is a Vernier scale. The divisions on main scale, they are known as MSD, main scale division. The divisions on the Vernier scale are known as VSD. Those are Vernier scale divisions, right? This scale is always fixed, right? This is a movable scale. One scale is always fixed. Second, it is a movable scale, right? So this is what, and Vernier caliper, right? Up to 2 decimal places. Generally, it can measure up to 3, 4, right? But the value will come that will be the less accurate, but up to generally 2 decimal places, right? Calipers are used. Apart from this, right? If you want to measure, see, there are the 3 applications of the calipers, right? Basically, there are 3 applications of the calipers. What are those 3 applications, right? What are those 3 applications, right? I'm writing down here. Okay, see, applications if I'm talking about. First, it can measure the internal diameter of the hollow cylinder, right? Okay, it can measure the external diameter, right? And it can measure the length. This 3 things the caliper can measure. How? Right, we are going to see. So this is what an important stuff about the Vernier caliper. But how this thing are going to happen, right, we are going to see. First of all, let's move on to, right, what actual the caliper is, right, and its least count. And apart from this, I want to give you some detailed introduction, right, here. See, okay, this is a main scale, right, okay, and apart from this, there is one movable scale, right? Okay, above it there is one movable scale, right? And that is the Vernier scale, like this way, right? Arrangement is there. Okay, like this way, arrangement is there. Okay, so this one is a Vernier scale, and that is a movable scale, and this scale is a fixed scale. It is known as main scale. One is a Vernier scale, second it is a main scale. The divisions on the main scale is usual 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, like this way. Here 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like this way. 0 starts here, 0 starts here, right? Okay, now this is what actual situation is right now. I want to tell you all about. Okay, this is okay. Can you see this part? These are known as upper jaws, right? And this part are known as lower jaws. Jaws in another sense, jaws to grab something, right? Jaw of lion to grab something, right? Upper jaw is used to measure the internal diameter, like when hollow cylinder is kept like this way. This is used to measure the external, and here we can measure the length of the hollow cylinder like this way, right? So these are the 3 applications and how they are measured, right? How they are measured. If we are having 2 scales, it means we are having 2 kind of readings. If we are having 2 scales, see, Vernier caliper, it is important to understand the, right, okay, that is a small difference between caliper and screw gauge, right? And that is the calculation of least count, right? Big difference is there, right? That is, analogy is same, right? If you are getting this topic right into the very convenient manner into your mind, you're getting, if your fundamentals are clear related to this topic, then with screw gauge, right, it will be quite easy, right? Upper jaw, lower jaw, upper jaw for the internal diameter, lower jaw for the external diameter. This one is for the length of the cylinder. 2 scales, main scales, Vernier scale. Vernier scale is a movable scale, main scale is a fixed scale, right? This is a screw, okay? This screw, right, helps us, right, okay, helps Vernier scale to move, right, back and forth, back and forth, back and forth. Now, Basically, we are going to deal with the three stuff. The first one, that is a least count error. What is the least count? See, generally, if I am talking about the least count, minimum measured value on an instrument is minimum, not smallest measured value. Smallest, this is an actual definition of a least count. Smallest measured value on an instrument, that is known as least count. Let's not move on to, we are not going on to the technicalities right now. The smallest measured value on an instrument, it is known as what? Least count. I'm sorry. Okay. The smallest measured value, right? Now, see, you can see this stuff, right? Okay, two scales are there. This is a Vernier scale. Now in this, see, if I'm talking about one main scale, this is my main scale, right? And this is my Vernier scale. There are divisions on main scale. This is 1. This is 2. This is 3. Similarly, this is starts with 0. This starts with 0. 1, 2, 3, 4, 5. 2, 3, 4, 5. This 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 2. Like this way. Right? Okay. This is the Vernier scale. This is a main scale. Now, what is the least count? The distance between the two main scale division, that I am saying 1 MSD. The distance between the two Vernier scale division, I am taking it as a 1 MSD. So I want to ask you all, the distance between the two divisions on the main scale, is it the least count? Is it the smallest value we are measuring on an instrument? The distance between the two divisions on the Vernier scale, right? Is it a least count? Is it the smallest value we are measuring on an instrument? Question mark. Generally, whenever we are seeing, let us take an example. Oh, we are seeing an instrument in front. Very nice. Okay. So on the very first attempt, we can say yes, 1 VSD. Yeah, that's a least count because it is the smallest measure. No. If I am aware of what is an actual value of 1 MSD, suppose let us take an example, right? Okay. This is 1 MSD, right? This is 1 VSD. 1 MSD is the smallest value? No. 1 VSD is the smallest value? No. Difference between 1 MSD and 1 VSD is the smallest value. So that's why we are using this formula, least count, that is equivalent to 1 MSD minus 1 VSD. Right? The difference between these two, right? The difference between these two, right, is the smallest value measured. The difference between these two is the smallest value measured and it is the least count, right? What is the definition? A least count depends on an instrument, right? In Vernier Calliper, we are calculating like this way. In screw gauge, right, we'll calculate into the different way. Okay, in caliper, we are calculating in this way. In screw gauge, we will calculate into the different way, right? So the smallest measured value, right? Why we are using this formula as the least count? There is a reason behind it. Why? Is 1 MSD is the least count, smallest value measured? No. 1 VSD? No. Difference between them is the smallest value measured. Smallest value measured doesn't mean by an eye. No. Right? Okay. So that's an actual concept of the least count. And what is the formula of least count? This one, 1 MSD minus 1 VSD. Okay, now. In Odisha NEET 2019, a separate paper was kept, right? Okay. So the main scale of a Vernier caliper. So this question related to the least count was asked. The main scale of the Vernier caliper has n divisions per centimeter. Okay, n divisions of Vernier scale coincides with, see, n divisions of Vernier scale that coincides with n minus 1 divisions of main scale. This data is given. Now we need to calculate the least count. There is another name of the least count and that is Vernier constant. Theoretically, in this syllabus, we are considering Vernier constant and the least count as same, but actually there is a bit difference. So this data is given. right? This data is given. Now what we need to calculate? We need to calculate the least count, and it is given 1 MSD, right? That is of n divisions, right? 1 MSD, it is of n divisions per centimeter. Okay, n divisions per centimeter it is given. Okay, n divisions per centimeter it is given. Okay, no worries, right? Okay, let's give you all a minute to solve this stuff, right? And we are going to see the solution. Okay, so see, first of all, we are using this data 1 n VSD, that is equal to n minus 1 VSD. Okay, see, n VSD, that is equal to n minus 1 of MSD. So in this case, what we are going to do, 1 VSD, that is equal to n minus 1 by n of MSD, right? Can I consider this as equation number 1? Yes. Now, what is an actual formula of least count? Right, least count, that is equal to 1 MSD minus 1 of VSD, right? 1 MSD minus 1 of VSD, right? Now what is 1 MSD, right? Can I write it as 1 of MSD? Can I replace value of the 1 VSD, that is n minus 1 by n, right? That is of VSD, sorry, MSD. Okay, this will be MSD. Okay, okay, so it will be n into n minus, it's 1 by n of MSD, right? This is the least count, but still we need to replace the value of MSD. The main scale of a Vernier caliper has n divisions per centimeter. Kindly mark my words, n divisions per centimeter. In 1 centimeter there are n divisions. So what will be the distance between the two divisions? That will be 1 MSD. Can I say it is 1 by n? In 1 centimeter, n divisions. What will be the distance between the two divisions? 1 by n. Very simple thing, right? So finally, can I replace as MSD as 1 by n? So our answer will be 1 by n square. C will be the perfect answer for this specific equation, right? So the least count of instrument, it will be 1 by n square. So this is how the least count is calculated, and it has been asked into the examination, right? Generally in JEE examinations, right? Okay, to calculate the true values are always, to calculate the total readings are asked, right? But in NEET, see, if I'm analyzing the paper before 2017 or 16 now, and this kind of the questions were not there, right? But since 3 to 4 years, the pattern is, right, we are feeling the competition. So that's why we need to focus. The NEET aspirants should also focus on this kind of topics, right? The NEET aspirants should also focus on this kind of topics, right? So this was the least count. Now what is another? A Vernier caliper has 1 mm mark. See, 1 MSD, that is equivalent to 1 mm. 20 equal division on Vernier scale with, okay, see, 20 VSD that coincides with 15 MSD. Same procedure you need to follow. Now here we are using what is the Vernier constant. Okay, let's move on. Let's give you all a minute to solve this stuff. Okay, see 1 VSD, that is equivalent to what? 15 by 20 of MSD. So that will be 1 by 4. Sorry. Okay, just keep like that way only. Okay, now least count formula is 1 MSD minus 1 VSD. So can I say it is 1 minus 15 by 20, right, of MSD. So that will be 0.25 of MSD. Now 1 MSD, that is equivalent to 1 mm, right? So what will be the value of the least count? That is equal to 0.25 mm, right? 0.25 mm. Okay, 0.25 mm. Okay, so here yes, B will be the perfect answer for this specific question. Now, zero error. Basically, what is a zero error? Whenever the instrument is constructed, now it is calibrated like that way only. Whenever the instrument is constructed, it is calibrated like that way only. That the zero of the main scale always coincides with the zero of the vernier scale. See, this is a main scale, this is a vernier scale. The zeros are exactly coinciding, right? The one is a main scale, the second is a vernier scale. The zeros are always coinciding. They are calibrated like that way only. Okay, they are calibrated like that way only. But we are using a lot, we are conducting the experiment, and there is a lot. Okay, there is a more use of a calipers into the right into the measurements, right? So in that case, okay, errors arises whenever object is not kept and both jaws touch together. See, this kind of words are used for the zero errors, right? Okay, first, object is not kept. Object is not kept, right? Whenever the object is not kept or both jaws are touch, both jaws touch together. If, right, just keep one thing in your mind. If object is not kept, both jaws touch together, then what will happen? Three possibilities. Zero of the main scale exactly coincides with the vernier scale, no zero error. But if zero, let us take an example. This is the vernier scale, this is main scale, right? This is upper one is the right vernier scale, and this one is the main scale, right? Upper one is a vernier scale and lower one. In this, see here, this zero of vernier scale lies behind, right? When objects are not kept, zero of main scale. In this case, zero of vernier scale no, just hold on, just hold on. Okay, the divisions are less, just hold on, I'm giving you the stuff. Okay, just hold on. Okay, we are repeating it again. See which one is the main scale, right? Okay, this is a main scale. Okay, because 1 MSD is larger as compared to the 1 VSD, right? Okay, 1 MSD is larger as compared to the 1 VSD. Okay, okay, yes, this is a main scale and this is a vernier scale. Okay, vernier scale is always having the, what we can say, 1 VSD is always smaller. In some of the cases there is a possibility 1 VSD may exceed MSD, but in those cases are resolved into a different way, right? Okay, so upper one is a main scale, right, and lower one is a right vernier scale. Okay, upper one is a main scale and lower one is a, see, you can see na, this is 0 to 1 and this is 0 to 1, so this length is shorter, right? Okay, so this one is a main scale, okay, vernier scale, and this one is the main scale, right? Zero of vernier scale is ahead, zero of right vernier scale is behind. If exactly coincide, then there is a no zero error. If exactly coincide, then there is a no zero error. But if zero of the Vernier scale is ahead, right, and the zero of the, right, if the zero of the Vernier scale is ahead as compared of the main scale, and if zero of the Vernier scale, right, it is beyond the main scale. Now what will happen? In the first case, right, if we are considering this stuff, okay, so this is a negative zero error, right? This one is the negative zero error, right? Okay, this one is negative zero error, right? And this one is, right, positive zero error. Right, upper one is a main scale and this is a lower scale, right? Negative zero error and positive zero error, right? Formula of the zero error, right, it always, that is equal to n into the least count, right? Nth is a division coinciding, right? Which division is actually coinciding? Like this way, see, this division is exactly coinciding, so that division is nth division, right? That division is exactly coinciding, so that division is what? Nth division. Similarly, in this case also, which division? This division is exactly coinciding, right? Okay, so here it is a positive zero error, that is positive n into least count, and here this will be the negative zero error. Sorry, this is a negative zero error. Okay, this is a negative zero error, and this one is a positive zero error. Okay, this one is a positive zero error, so this will be positive n into the least count. What will happen into the total reading? We are going to see this stuff, right? Now how we can directly solve, right? See, questions related to zero errors are not asked, right? But in this stuff, how we can see actual reading, okay, question solving approach for this, right? See, what will be the total reading? That is, the total reading is always, right, the total reading is always, right, reading of main scale, right, plus reading of Vernier scale plus or minus zero error, right? Okay, minus zero error. Okay, the actual formula is of minus zero error. Okay, it's not plus or minus, right? I wrote it because many students are having the confusion, right? In many of the resources, right, it has been taught into the different way, right? But this is an actual formula, that is, it has been, that's why it is written into the different color. The total reading, that is equal to MSR plus VSR minus zero error, right? Okay, what will be the value of MSR? That is nth division coinciding, or sometimes, right, the actual reading and question solving approach for this caliper. How the total reading is calculated, and based on this, how sums are asked. See, the total reading, I can say that is equivalent to the total reading, I can say main scale reading plus Vernier scale reading minus zero error. Main scale reading plus Vernier scale reading minus zero error, right? So in this case, if I'm talking about the total reading, right, see, main scale reading is always given, right? Vernier scale reading, it is always nth division coinciding into the least count. This nth division, right, coinciding between, right, main scale and Vernier scale, right, when object is kept, right, when object is kept. Always coinciding between the main scale and Vernier scale when object is kept, right, when object is kept. And for zero error, we are having the formula, that is n into least count, right? This is the nth division coinciding when object is not kept. object is not kept. So this is an actual formula, and this is only the question solving approach, right? This is only the question solving approach, how we are going to solve this question, right? Question solving approach. Okay. Now let's see the first question, right? Let's see the first question. The diameter of a cylinder is measured using the calipers with no zero error. Okay, see, you are lucky, no zero error is given. But if I'm talking about the zero error here, suppose it is a negative zero error. See, for zero error, right, I'm writing it is a negative zero error, then we can write it as negative of negative zero error, right? So it will get add into the total value, and if it is a positive zero error, then it will get, right, the, okay, subtracted from the actual value, right? Okay, so here zero error of the two kind, we already discussed that stuff, right? Zero error is of the two types. Okay, so now the diameter of the cylinder measured using the Vernier caliper with no zero error, it is found that zero of the Vernier scale lies between this and this. So it means that here it's 5.1 and this is 5.15, right? Okay, the zero of the Vernier scale lies between this somewhere, right? Lies between this. It's a zero of VSD, right? So it means that our main scale reading is, right, main scale reading is 5.10, right? Main scale reading is 5.10. Okay, so this was just a simple explanation. Now what they are saying, let's see. Okay, no zero error is given, right? The Vernier scale has the 50 divisions equivalent to 2.45 centimeter. The Vernier scale has in 2.45 span of centimeter and 2.45 centimeter of that length. 50 divisions of the Vernier scales are there. The 24th division exactly coincides with one of the main scale division. Then what is the diameter? Let's give you all a minute to solve this stuff, right? It's very easy, right? We have to just apply the total reading formula, right? We have to just apply the total reading formula. Come on. Okay, see, first of all, I want to tell you all, right? Okay, first of all, I want to tell you all, see, what is the actual formula of the total reading? What is an actual formula? We are going to use that formula, right? We are not aware of the least count, first of all, right? Okay, the total reading, right, that is equivalent to MSR plus Vernier scale reading minus zero error. This is an actual formula we are using, but here it has been described there is no zero error. So it means that total reading that is equal to MSR plus VSR. MSR reading we got as 5.15. So that is 5.10. Okay. See, whenever there the zero of the Vernier scale lies between this two, right? There is no deal. There is no, right? Always take the left side value. Always take the left side value. So that is 5.10 plus. Formula for the main scale, that is n into least count. What is the formula? See, 5.10. It is written in centimeter. Okay, plus. Which division is coinciding? Right, it is 24th division coinciding. 24th division. So n value is 24 now. The formula of least count, it will be 1 MSD minus 1 VSD. Right. Again, I am repeating, this is a total reading MSR plus VR minus 0. MSR 5.10, it is given. 24 division is coinciding. Now we need to calculate the least count, that is 1 MSD minus versus 1 MSD minus 1 VSD. Now, okay, see 5.10 centimeter and 5.15. The reading is this between this two. So if I'm imagining this situation, 5.10, there is a bit of error, yes, 5.15. So it is 1 MSD, that is equal to 0.05. Okay, now 1 VSD we need to calculate in 2.45, right, whole divided by 50. So it is 0.049. So least count will be 1 MSD minus 1 VSD. So it is 0.05 minus 0.049. 0.001 it is, I'm sorry, 0.001, right, 0.05 minus 0.049, yes, 0.001 it is, extremely sorry. Least count will be 0.001, so it's 0.001, so it is 5.10 plus 0.024, so actual reading will be 5.124. okay, here the small mistake we did, we write it as 0.01, but not, it is the actual reading is 0.001. So B will be the perfect answer for this specific question, right? Okay, I think approximately 3.5 hours of the lectures, right? Approx 3.15 hours of the lectures we have completed, right? But still we are there, okay? Because one micrometer screw gauge is there. So this is how the actual thing is calculated, right? This was the sum. Now let's move on to the next part. This is a PYQ online, April 10, 2015, right? April 10, 2015. This is a sum with the zero error. Oh, nice. This is a sum with the zero error. Zero error is directly given. The diameter of the steel ball is measured using the Vernier Calliper, which has divisions of 0.1 centimeter on its main scale. And 10 divisions of Vernier scale matches with 9 divisions on the main scale. Okay, for this three measurements, right, zero error is this, then the mean corrected diameter will be what? The mean corrected diameter will be what? The mean corrected diameter will be what? Right? So let's give you all a minute to solve this stuff. Come on, everyone. Okay. Less than 10 seconds remaining. Come on, everyone. Less than 10 seconds remaining. See how to solve this stuff, right? See, first of all, see, we are having the three, right? We are having the three observations, na? Right? It means we need to calculate the average, right? We are having the three, right? So it means we need to calculate the average of all of those. First of all, I will calculate the least count, that is 1 MSD, right, minus 1 VSD. Now in this question, it is always given, okay, the 10 divisions. So 9 MSD, right, that coincides with the 10 VSD. So it means that 1 MSD, that will be equivalent to 9 by 10 of 1 VSD, that is equivalent to 9 by 10 of MSD, right? 1 VSD, that is equivalent to 9 by 10 of MSD. So replacing here, we are getting least count as 1 by 10 of MSD, that is 0.1 centimeter, right? So here the least count, we are getting it as 0.01, right, centimeter. Right, least count, because one main scale division is of 0.1 centimeter, so we are getting this least count. Okay, now what will be the total reading? Okay, see, 3 values are given, then it means we need to see what our formula says. Total reading, that is equal to main scale reading plus Vernier scale reading, right, minus 0 error, right, minus 0 error. But here you can see then 0 error is negative. It means whenever we are going to replace this into the equation, we'll get the positive value, right? Whenever we are going to replace this in the equation, we are going to get the positive value, right? Right. So what will be the total reading here? We are going to get the average of this, right? Indirectly, if we are saying, see, total reading, main scale is of 0.5, it is fixed. So it means it is 0.5, it is in centimeter plus. See, what is the formula of, see, if I'm Vernier scale, that is n into least count. So here only I'm taking the average, right? Here only I am taking the average, that is 8 plus 4 plus 6 whole divided by 3 into least count, right? So 8, 16, 18 by 3, that will be 6 into least count, right? Rather than taking, see, it is a very simple thing, rather than to calculate for the first one and get the total reading, right? Then to calculate for the second one and get the total reading, then to move on for the third one and get the total reading, and to take an average of the total readings of the 3 values. Instead of that, we are directly using this, right? We are taking the average of this only, and the rest of the things are completely common, right? 0.5 is a common, right? Number, this least count is a common value. So instead of doing multiple times, we need to save our time. So what we did, we calculate the average for this. So it will be 6 into 0.01 minus 0 error will be negative of 0.03. Okay. So finally we are getting the total reading as 0.59 centimeter, right? 0.59 centimeter. Okay. So the B is a perfect answer for this specific question. Okay, so this was the complete concept about the okay, this question this has been asked in September 2, 2020. I'm giving you all for the homework, right? Okay, you can just answer this question beneath the video. Same, see, in this kind of the question, see, you can see the lots of sentence formations and grammars are there. Lots of sentence formations and grammars and this kind of things are there. You don't have to worry about it. Okay, so let's see the glimpse of the caliper, what we have seen, but it's okay, we have seen, it's not a big deal. If you want to have the glimpse of it, right, you can just check it out. Okay, see, caliper, why caliper and Vernier caliper, right, this thing, least count and everything, okay, this thing, okay. 0 error, there is no need. In many questions, 0 error is given directly. Okay, so this one question I gave you as the homework, right? Now Micrometre screw gauge. See, if you are completely aware of the, right, Micrometre screw, this Vernier caliper, na, right, then it will be quite easy to understand this stuff, right? It will be quite easy to understand this stuff, right? It will be quite easy. Now, what is a Micrometre screw gauge? As I said, what was the need of this Micrometre screw gauge, right? It's a very simple thing. What was the need of that? So, as I said, it's a very simple thing, right? It's a very simple thing. If I want to measure up to 3 decimal places and more than that, then obviously the meter sticks and measuring steps are going to fail, right? Okay, these things are going to fail. So for that, we are going to use this Micrometre screw gauge, right? Okay, for that, we are going to use the Micrometre screw gauge. Okay, so this Micrometre screw gauge, as I said, it is used to measure the, right, diameter of cylinder. Diameter is not cylinder. Diameter of sphere, and second, thickness of thin sheet. These are two the best examples of the applications of, right, Micrometre screw gauge. The best examples for applications of Micrometre screw gauge. This is a visualization, right? And there is an everything in this visualization, right? Okay. First, the movable thing, you can see it is spindle. As like Vernier caliper, in Vernier caliper, though we are having 2 scale. Here also we are having 2 scale. The first one is a Vernier scale and second one, that is a circular scale. In caliper, Vernier scale was fixed. Here also Vernier scale is fixed. In caliper, Vernier scale was, in caliper main scale was fixed. Here also main scale is fixed. In caliper, Vernier scale was moving. Here the circular scale is moving. In caliper, vernier scale was covering the linear distance. In circular scale, the caliper, this circular scale is covering the angular distance. Right? Main scale fixed. In caliper, it was fixed. Movable vernier scale in caliper, yes. Movable circular scale in screw gauge, yes. In caliper, movable scale was covering the linear distance. In screw gauge, the circular scale is covering the circular distance, the angular distance. Not circular, but an angular distance, right? Okay. Object is kept here like this way, right? Using ratchet, okay? The scale is rotated and this thing is moving forward, and there this spindle is trying to grab the object, right? So this is what an actual phenomena of this thing, right? Least count in caliper, least count in screw gauge, right? Okay, now let's see what it is. Pitch. If I'm talking about the main scale, what is a pitch? What is the least count? What is the pitch? Right? Okay. If we want to define this stuff, how we can define? Suppose let us take an example. This is a main scale. Right? Okay. See, formula of the least count in this, it is different, right, as compared to the Vernier caliper, right? Formula of the micrometer screw gauge is different. Least count for micrometer screw gauge is bit different, right, as compared to the Vernier caliper. But how it is different, we are going to see. What is the total distance traveled on the main scale on completion of the one circular rotation? On completion of one circular rotation, on completion of one circular rotation, the linear distance traveled on main scale. This device is designed like that way. When we are rotating completely, okay, one circular rotation is completed, right? Then what is the linear distance traveled? Like this way, one rotation is completed, the linear distance traveled, right? Okay, that is the pitch, right? That is the pitch, right? Okay, so that is the pitch. So on the main scale, let us take an example. This is the circular scale, right? It is completing one rotation, right? How much amount of the distance is traveled? That is the pitch. Suppose the distance between two divisions is traveled, then this will be the pitch. Suppose distance between the half of the division is traveled, right? This much amount of the linear distance it is covering, then that will be the pitch. This is an exact definition of the pitch. Now, what is the least count? The important definition lies here, right? Okay, so here it is, the screw gauge has the least count of this and there are 50 divisions. Okay, we are going to solve. See, this question has been asked in, right, NEET 2020. We are going to solve this. Why? Because in this, the formula of the least count has been used, right? So we need to solve it here. Now, what is the least count? The smallest, right, value measured on an instrument. The smallest value measured on an instrument, right? The smallest value measured on an, same as we have seen into the caliper. The smallest value measured on an instrument, that is known as least count. But here the concept is quite different. Is the distance between the two divisions on the main scale is a least count? Wrong. Is the distance between the two divisions on the circular scale, it is a least count? Wrong. Then what is the least count? The difference between these two is a least count? No. How to travel the smallest? How to measure? See, in caliper, what was the way to measure the smallest value? 1 MSD minus 1 VSD. But here, how we can measure this? How we can have the smallest measurement, smallest value on this instrument? See, what was the definition of pitch? On one complete rotation, the linear distance traveled. See, suppose this, on one complete rotation, this. On one complete rotation, linear distance traveled on main scale is pitch. Is it compulsory to complete the entire rotation? Can I complete half? Suppose one complete rotation, this distance, say this is pitch. One complete rotation pitch. What about half? What about less than that? So can I say now when was just about to start the rotation? One complete rotation pitch. When I was just about to start. Then the linear distance covered, it is known as least count. So what it will be? Pitch whole divided by number of divisions on circular scale. Pitch divided by number of divisions on circular scale. One complete rotation, pitch. Just about to start rotating, some fractional part of pitch. Some fractional part of the bit, that is the least count. So there is a difference. It was smallest 1 MSD, 1 VSD caliper. Here, one complete rotation pitch. Right? Okay. Okay. But this one. Just about to start, it is a least count. Now we are going to solve this stuff. A screw gauge has a least count of this, and there are 50 divisions on the circuit. And the pitch of the screw gauge is what? Come on. Okay, you are having right this thing. Very simple question it is, yaar. Very simple. So simple saying like least count, that is equal to pitch whole divided by number of circular scale divisions, right? The least count is 0.01. So pitch, it will be what, right? 0.01 into 50, right? So we are getting pitch as 0.5 mm, right? So this is the perfect answer. See, this kind of the question is asked in NEET 2020. The C is the perfect answer. Okay, now let's move on to the next part. Okay, the question that has been asked in September 6, on September 6, 2020. The screw gauge has a 50 divisions on the circular scale. The circular scale is 4 units and ahead of pitch, right? Prior to use. Okay, this is least count. Okay, the nature of the zero error is involved and the least count of the screw gauge are respectively. Okay, see, a screw gauge has a 50 divisions on the circular scale. So it means that number of divisions, that will be 50. The circular scale is 4 units ahead of the pitch scale, marking prior to use. The circular scale is, right, 4 units ahead of pitch scale marking to use, right? Upon one complete rotation of the circular scale, the displacement is point. See, one complete rotation, the displacement is 0.5. So it means pitch will be what? On one circular, it will be 0.5 mm, right? It will be 0.5 mm. The nature of the zero error is involved and the least count of the screw gauge are respectively. It means we need to consider the nature of the least count, right? So either we can have the positive, right, or we can have the negative, and it is written 4 units ahead of the pitch scale. Okay. No worries. Let's give you all a minute to solve this stuff, right? It's very easy and it's very simple also, right? Come on, everyone. Okay, see. First of all, right, see, we can understand the least count, that is pitch, whole divided by number of circular. So this is 5 divided by 0.5 mm, right? Okay, 0.5 divided by 0.5 mm, right? So what it will be, right? The least count will be approximately 0.5 mm, right? So it will be approximately, right, 0.5 mm, na? Right? Yes, so it will be 10 micrometer. Okay, least count will be 10 micrometer. Okay, it is 0.5 and 50 divisions are there. Arey yaar, I'm this kind of the errors, right? Okay, 0.5 by, okay, I've written, right? Okay, this will be 10 micrometer, that is 0.5 whole divided by 50, 0.5 mm whole divided by 50, right? So this will be 10 micrometer approximately. Now, whether it will be positive or negative, see, 4 units ahead of the pitch scale, right? 4 units ahead of the pitch scale. What it means, right? See, right now I am saying this is a positive 10 micrometer answer, right? Least count is not going to change, right? But we have to take the nature of the zero error. Right, we got our least count is 10 micrometer, yes, but whether it will be positive or negative we are going to see in just a couple of minutes, because we need to consider the nature of the zero error. And zero error I haven't explained till now. What is a positive zero error, what is a negative zero error, right? Okay, so right now just consider this is a 10 micrometer and the rest of the things we are going to see right now. Okay, see, zero error. Suppose the zero of the main scale exactly coincides, right? Suppose the zero of the main scale, see, there is always a reference line. This is the reference line, right? Suppose this zero exactly coincides, then we are having the no zero error. Suppose zero is beyond, then it is a positive zero error. Suppose zero is above, right? What is the formula of zero error? That is n into the least count, right? What is the formula of zero error? That is n into the least count, where n is the number of divisions. In Vernier Calliper, it was nth division coinciding. Here, n is the divisions whether zero is above or beyond. Here in this case, this is 1, 2. 2 divisions beyond the reference line. Here, 1, 2, 3, 4. The 4 divisions above. Here, 2 divisions beyond the reference line. Here, 4 divisions above the reference line, right? So n divisions, right, above or beyond the reference line. Okay, above or beyond the reference line. So this is no zero error, positive zero error and negative zero error, right? So what will be the nature of the zero error? See, here they have said, okay, in this question, see, in this previous question, okay, the 4 units ahead of the circular scale is 4 units ahead. It means nature of the zero error is positive. 4 units ahead, you can see this stuff, right? You can suppose, so this was a reference line, right? Okay, so zero, see, this is 4 units ahead. Okay, I'm just showing the statement. It is a possible, this analyze this scenario, right? Okay, and this is, see, the circular scale is 4 units ahead of the pitch marking prior to use. So when object was not kept, right, the spindle was completely touching the dot, right? Okay, then the circular scale was 4 divisions ahead. It means we are having the right positive 0 error. Okay, positive 0 error. So that's why here we got the formula from we got the answer of the least count as it, but nature is positive, right? So this question has been asked in September 2020. Okay, again in this actual reading is that the total reading, that is equal to main scale reading plus circular scale reading, right, minus 0 error. Okay, so here main scale reading is always given into the question plus circular scaling, it is like, right, okay, n into the least count, okay, minus 0 error n into the least count, but there is a difference. This n, right, when object is kept, right, and this n when object is not kept. When object is kept, when object is not kept. So this is an actual formula, and this thing we have already seen in this. Now, okay, let's move on to the first sum. I'm sorry. The pitch and the number of the divisions on the circular scale, are, see, it's a very simple thing. Okay, pitch, it is 0.5. Okay, directly we are calculating pitch divided by number of divisions. It is 0.5 whole divided by 100. So that is 0.005 of mm. When the screw gauge is fully tightened without any object, the 0 of the circular scale lies 3 division below. 0 of circular scale lies 3 division below. So it means we are having the positive 0 error, right? And that will be equivalent to, right, a number of divisions, 3 divisions into the least count into 0.005. So that is 0.015 mm, right? So this is the first part, this is the second part. Now, the main scale reading of this, right? So now see, total reading will be what? Okay, the total reading will be what? Okay, so now the pitch of the number of the divisions on the circular scale for the screw gauge is 0.5 and number of divisions are 100. When the screw gauge is fully tightened without any object, the 0 of the circular scale is 3 division below. Okay, first of all, let's move on to the least count, that is 0.5 whole divided by 100, and it will be 0.005 mm, right? Now, it has been said when it is fully tightened, we are not giving it a time, we are directly resolving it, right? Then without the 0 of the circular scale lies 3 division below the main line. So it means we are having the positive 0 error, right? We are having the positive 0 error. So it would be like, okay, number of division into the least count, 3 divisions. So it is 0.015 mm. Now what will be our total reading? The total reading that will be equivalent to main scale reading plus circular scale reading minus 0 error. 0 error we got it as negative of 0.015. Main scale reading it is given as 5.5 mm, right? Okay, plus circular scale reading how much? 48 division coincides when object is kept. So 48 into 0.00, right, 5. Okay, so whenever we are solving this, we will get the answer of 5.725 mm. Okay, it has been asked into the 9th January. Simple direct formula is there. Without wasting the time, we can apply, right? Direct formula is there. Next question, it is also having the direct formula. Just there is a small sentence formation. See, 2 turns, right? 2 turns of a circular scale that covers a distance of 1 mm. 2 rotation, linear distance 1 mm. Then on one rotation, linear distance is of 0.5. So it means here the pitch will be of, right, 0.5 mm. Total number of divisions are 50. What will be the least count? The least count, that will be is equal to 0.5 whole divided by 50. So it's 0.01 mm. Right, this will be the least count. Right, 0.01 mm, that will be the least count. See, what will be the pitch? 0.5 mm. Right, number of the divisions on the circular scale, that will be 50. It is given into the question. And then what will be the, right, what will be the least count? It is very simple thing. Right, what will be the least count? 0.01 mm. So, okay, so while measuring the diameter of the thin wire, okay, see, zero error is negative, so we are not in that. So we are directly applying the formula. Total is MSR plus CSR, right, minus zero error. Right, what is the main scale reading? That is of 3 mm, right, 35 division coinciding, so it is 35, right, into, okay, least count is 0.01, right, minus zero error is negative, so it is negative of 0.03, right, so this will be 3 plus 0.38, that is 3.38 mm will be your reading. D will be the perfect answer. The same formula we need to apply, right, the same formula, right, there is no need, the same formula we need to apply. Okay, so in the questions where there was a need, I gave you all a minute. In the questions where we need to directly resolve, then we are not going to waste that time. Okay, so here that was a screw gauge, right? So guys, in this lecture we moved on with simple thing. We moved on with physics, physical quantities, types of physical quantities. We saw dimensional formulas, plane angle, solid angle, dimensional formulas. We saw one of the applications for this, right? Slowly we moved on to the concepts of errors, and we saw the relevant sums, right? And after that we moved on with the concepts of this one, the measuring instruments, and all of the stuff in this with the flow chart and everything is there, right? So guys, thank you. I would be waiting for your comments in this. Beneath the video, you have showered the love, lots of love into the KVPY series. Same thing you have to do here. I will be waiting. See, all of those comments I'm reading, right? I will be reading all of your comments beneath the video, but I can't reply for each and everyone. Okay, so I will be waiting for your response. Thanks a lot for those who are watching till now, right? Hope so you got something from this lecture, right? So guys, this is Indrajeet Singh signing off from the desk. Bye bye, Sat Sri Akal and Namaste from my side, Bachcha. Bye everyone. Stay at home, stay safe, stay healthy amidst the pandemic. Bye, Bachcha ji.